Okay. Good morning, good night, good evening. Welcome all. I am admitting folks here as we start our final session. It has been a month. Can you believe it? I feel like this has gone quite fast, and it has been a really humbling experience to be of service to all of you. So I'm going to start our translation. Shireen, thank you. First thing I'm going to do is I'm going to start the translation, and I'm going to share my screen just to remind everyone to do so. Okay. Great. You should be able to see. Okay, let me start her interpretation. Okay. So welcome to the fourth session of our quantum literacy program. We are really excited to have you here. And today we're going to be announcing our winners. The way that our agenda is going to go is we're going to talk, well, it's going to be a mixed match, but we're going to talk about career continuum, quantum for good. We're going to have our award ceremony. So while we are gathering here, just make sure that you take a look at your language settings. Your language settings are really important because we are going to be going from one language to another, and it is a seamless experience if you follow these steps. So we are at 8:04, so we're just going to get started. To my awesome co-organizing team, if you could please have your added in the chat as a reminder with the steps, that would be awesome. Very well. So just a quick recap of the folks that are making this possible. That I am Nydia. This is Johan Carvajal Godinez. He's one of our core organizers from Costa Rica. He's a professor at El Tec and an associate research professor at El CNSA. Johansel Villalobos, he's another co-organizer, and he's also from Costa Rica, representative from the Colaboratorio Nacional in Costa Rica, the Center for Advanced Computing and Research in Costa Rica. And he is also the point of contact for Sanat. Last week he spoke to you. They both spoke in different events, one about sustainability and the other one about how to access supercomputing resources. I have been speaking to you about different things, gates, VQEs, algorithms, a whole bunch of stuff. So let me talk to you about Ayelen Perez. She is our co-organizer in Argentina. She just hosted a really successful event as well, where they were at full capacity in Argentina. It was hosted in the IBM Tower, and she is, we call her the networking queen. She has brought together so many people and so many connections and made things happen. Dani Beth Farnoon, she's our communications manager and co-organizer. She is located in the United States. She is from Panama, and our amazing coordinator with a lot of the things that we need to do. It takes a village. It really does. Juan Carlos Sanchez Perez, he is our co-organizer from Mexico. He was working on an event in Puebla. Now, Shireen Escobedo Guichero is our translator, simultaneous interpreter. She is from United States. Well, she is from Mexico, and she's currently located in United States. She's from both. Alex Gerard is our HR business partner and co-organizer as well. She is located in Durham, North Carolina. Dr. Karime Assaf is a program manager and co-organizer, also from United States and Costa Rica. In case you are wondering, yes, she is my sister. Now let's talk about our VIPs. As many of you know, We have some interns that have created outstanding material for you. We will be asking them to show their cameras later on, and just I really want you to take a moment to if you know to add some comments about different content or things like that, because some of the ways that the folks explains things really help drive the point home on some concepts. And it would be wonderful if you have something nice to say about something they created, that you let them know. Please post it on the live comments on Discord. So sponsors, remember, it is important for anything that happens that we understand that resources come in multiple ways. Sometimes it's time, sometimes it's money, sometimes it's space, sometimes it's resources of different kinds. So our sponsors, we're going to go through in a minute, and then we have partners and volunteers, folks that have either helped us make connections, supported us in either providing like a space to take something, volunteers that said, you know, let me help you with this, or I know a contact for this or that. So we are very grateful to all of those. Your hosts, I am the founder of Enluz, and we focus on strategy for human and machine. You can all look up what we do a different day. Al Colaboratorio Nacional de Computación Avanzada, they do amazing research. They're brilliant people, and they are working in Costa Rica. One of the things that we were speaking with Johansel and the team was that after this, we want to make sure that the connections and the networking that has taken place has a space for you to continue working and researching, and maybe talking to other folks about opportunities on what could be continued research. It is very important, especially now. Some of the challenges that are out there are looking for multidisciplinary teams, meaning a physicist, maybe an engineer, perhaps a doctor. You might need individuals that know how to work within certain data scenarios. And you will find that, for example, today I went to the NIH competition and challenge that I had shared with you last week. There is $1.3 million that can be won. So one of the key rubrics that they had was the diversity of team. Did you have all the experts? And you can only achieve that with networking. Tell people what you need, what you can offer. The channels for networking are still open in Discord, and they will remain open. If you're looking for someone to do additional research in, or you may want to connect to continue studying towards different certifications, please remember that this is a platform for you. The group that when we and Johan Carvajal and myself have co-founded Entangle Ket, which is based on some of the Native American Bribri language, which is to launch together. And it is very important to us to create that community for all of you to find a space where you can continue sharing your brilliance and achieving together. So keep that in mind. We're going to recap that at the end of this. Sponsors, IBM, as you know, Qiskit Fall Fest, you have to apply to become a host. And so if you like this, if you want to host it in your school, you can apply next year. Keep an eye on their blogs. Do it. Just go for it, and invite us. I love to learn from everyone. We're always a teacher and a student, so just know that this is also accessible to each and every one of you. Quarks Interactive, their game Quantum Odyssey was one of the coolest ways for me to understand really how optimization in qubits really made a difference, especially with large circuits. So I hope that the winners have a great time playing it, and those who are interested in it and may not get a license today, make sure you add it as in your Steam account, and that you keep an eye on their releases, because they have great games and competitions. QNow. You have heard from QNow as in several instances. Today, we're going to have some of their founders also speaking. So Danielle, who's going to be speaking shortly, is also one of the founders. And I love his presentation because as we are talking today about career continuum, there's a host of things that you could use. And his implementation, his project was used in a different platform, but nonetheless, it is critical for you to know that if you have an idea and you just try something that's out there, do not underestimate those badges that we shared with you, be it for the quantum fundamentals or the VQEs, or even some of the cryptography ones for KQD. And then partners also Senat, el Tecnológico de Costa Rica. There was a really awesome event there where they had a challenge on sustainability, and we had winners from that team with Johan and Johansen. Qubit Hub is a partner in Mexico. I was working with an event in Puebla. And then Entangled Cut is the community that we are going to take our Discord channel and continue keeping it open for continued conversations. All right, so we're going to go and introduce our speaker, Daniel Ruiz. Daniel is going to talk to us about quantum convolutions in X-ray images for lung segmentation. So Daniel is passionate about exploring the frontiers of technology, focusing on quantum computing and artificial intelligence. As the founder of QNow, he's dedicated to driving innovation and achieving technical goals. With over a decade of experience, Daniel has consistently pushed technological boundaries, creating a lasting impact by harnessing the transformative potential of emerging technologies. Now, let's give Danielle a welcome. And in the meantime, while I set up his different permissions, I want you to remember to select your language. Very important for you to select your language. So Danielle, I'm setting up your permissions now. And for Shireen, I'm going to ask you to switch your voice channel. So just a reminder, make sure you go and you select your language. And Danielle, let me know when you are ready.
Hola, hola, ¿se escucha?
Sí, sí se escucha. So
Okay.
just one last reminder, make sure that you set your language, go to the three dots, go to translation, and select English or Spanish, and I hope you enjoyed. Daniel, can you share your screen?
Okay, dame un segundo.
And Danielle, have you selected your language as Spanish? I know
Sí,
you
sí,
both.
sí.
Okay, great. Wonderful. Thank you. Okay.
Ok, genial. ¿Se ve la pantalla?
Se
So,
ve tu
can you
pantalla,
see my
pero no la
screen?
presentación.
Ok,
Yes, we can see your screen, but not the
un
presentation.
segundito. Ahí está.
One moment.
Ahí
Perfecto.
There we go.
Ahora sí. Adelante. Gracias.
Here we
Please,
go.
si pueden hablar lento para que la traducción pueda ser efectiva.
Please
Genial.
speak slowly so translation can
Listo,
be
no hay
done
problema.
easily.
Bueno, ¿qué tal?
No
Buenas
problem.
noches. Gracias, Nydia. Gracias a
Good
todos
evening, everyone.
pues, por
Thank
el
you,
espacio,
Nydia and
por
everybody,
esta oportunidad.
for the space and this
En
opportunity.
este momento, pues vamos a hablar de lo que
In
serían
this
las
moment, we're going to
convoluciones
talk
cuánticas
quantum
y ver de qué
convolutions
manera pues
and
podemos
see in which
empezar a
way
pensar desde ya
we
software
can start
para aplicar
thinking
al futuro,
of
ya
software
que
to
pues
apply
a
to the
nivel de software,
future,
a nivel de código, no
because in
estamos limitados como a
software
nivel de
level or
hardware, ¿no?
coding, we're
Nuestra
not
diferencia
limited
es
as we
que
are in
podemos bocetar
hardware. The
aplicaciones
difference
desde
is
ahora
we
sin necesidad
can
pues de un hardware
posit some
sofisticado o un
applications
hardware
without a
full
sophisticated
tolerance
hardware
y demás. Entonces,
or a
el
full
objetivo de esta
tolerance
Nydia es
hardware.
transmitirles
The objective
justamente eso
also is to
eh,
transmit
y darles
this
como
and give
el mensaje
you
de que desde
a
a
message
partir de
of
ahora pues podemos empezar a crear
starting
cosas
from
para
now
un mañana, ¿no?
that we
Así
can
que,
create things
bueno,
for tomorrow.
arranquemos.
So let's start. Let's get started.
Esta es la agenda.
The
Vamos a ver una
agenda.
pequeña introducción.
We're going to
vamos
see
a
a small
ver
introduction.
el,
We're going to
a
see
contar un poco de dónde vienen los datos, qué fue
a
lo que
little
se
bit
hizo.
of where
Este
data sets
fue
come from
un
and what
enfoque,
we
un
did.
acercamiento
This
personal
was a focus,
propiamente
a
para mi
personal
tesis de
focus
grado.
on
Así que bueno,
on
vamos a ver
my
un poco los detalles, qué
thesis,
fue lo que se hizo
and
y
we're going
por
to
qué
see
se
some of the
hizo, ¿no?
details of what we did and why we did it.
Vamos a ver un poco de redes neuronales,
We're going to see a little bit of
ya
neural
mezclándolo pues
networks
con computación cuántica
and
como tal,
mixing it up
los
with
resultados del
quantum computing,
experimento,
and then the
desafíos y
results of
las
the
herramientas.
experiment, some of the challenges and the tools used.
Bueno, puntualmente
Well,
la segmentación de pulmones
we
con la
start with
computación
the
clásica se
lung
hace de forma
segmentation
eficiente,
with classic
¿sí?
computing with an
Este es
efficient
pues
way.
el resultado final o lo
This
que
is the
o el
result, the
ejercicio
final
de hacer una
result,
segmentación de
or
pulmones.
the
Por lo
exercise of
menos este es el
making a lung
resultado con
segmentation,
modelos clásicos de redes
or at least
neuronales.
this is the
Se
classic
puede
result
apreciar en la
of
imagen pues
classical
que
neurons.
segmentar un
We
pulmón
can appreciate in the
eh,
image
se
that
hace de forma
there's a
pues
lung that's been
precisa
segmented
para el ojo o para
in a
em,
precise way for our eye to
desde un punto de
see.
vista general se puede ver que
From a
hay
point of
bastante
view, a
precisión
general point of
en solo
view,
el ejercicio de
that we can
segmentar.
see there's
El ejercicio de
quite a bit of
segmentar,
precision in
más allá de dar
segmentation.
contexto
This is an
en
exercise of
imágenes y demás,
segmenting
en
more
este
than
caso
a
puntual
context
de
in
segmentar
images.
pulmones,
In this
se
case,
une a otros procesos más complejos como el
is
de
joined with
poder
other more complex
diagnosticar cáncer.
processes
En
like
este caso,
being able to
ya nos
diagnose
metemos en la
cancer.
parte de los datos.
In this case, we
Se
went
agarró
into the
un modelo
data of it and we
con
grabbed the model
arquitectura UNET, ahora vamos a
with
ver bien en
architecture,
detalle, con datos
and we're going to
de
see in more
imágenes de
detail with
pulmones
data
sanos
of
y pulmones
lung
con tuberculosis, ¿sí?
data
Em,
that are lungs
el
that are
notebook
healthy and
clásico que tenía el
lungs
modelo
that have
clásico lo pueden encontrar
tuberculosis.
en Kaggle. Acá van
And
a
in the
tener
classic
los
model,
links
you can see in
a los
Kaggle,
datos y al
and here you
notebook
have the
original.
links to the notebook and data.
Obviamente que estos slides y el código se los vamos a
Obviously,
compartir.
this is the lights and the
Estarán alojados en un
code we will be
repositorio
sharing
público para que
in
ustedes
a
también lo puedan ver.
repository, a public
Pero como tal, el
repository for you
dataset
to see.
que se usó
But
fueron
the data set that we
aproximadamente
utilized
800 imágenes,
was approximately 800
de
images
imágenes de rayos X de pulmones.
of
Como
X-rays
les
of
contaba,
lungs,
particionado el dataset
as I
en
were
pulmones
telling
sanos y
you,
pulmones
partitioning the
pues
data
con
set of
tuberculosis,
healthy
¿sí?
lungs and
Em,
lungs with
Bueno,
tuberculosis.
para el
And
procesamiento de imágenes,
to
puntualmente
start the
con
processing
modelos
of
de Machine
images,
Learning, de Deep
we
Learning,
use machine learning
utilizamos redes
models
neuronales,
and
¿sí?
we
Las redes
utilized
neuronales,
neural
pues gracias a
networks.
su
And
versatilidad,
because of
nos
these,
permiten
their
procesar imágenes,
versatility
¿sí?
allowed
En este
us to
caso,
process
a
images.
nivel sencillo, esta
In
es
this
la ilustración
case, that
de
it's simple. This
una
is an
red
illustration of it, of a network,
neuronal que
neural
recibe
network
una imagen o de un perro o de
that
un
is
gato
receiving an
y
image of a
nos sirve
dog or a
para
cat,
clasificar
and
dependiendo pues
it
sus
serves us
características,
to
¿sí?
classify
Y
depending
demás
on the
operaciones y
characteristics
procesos que se
and
hacen
operations and
en las diferentes
processes
capas
that are
de una
done
arquitectura, ¿sí?
in the several layers of
Puntualmente,
architecture.
las redes neuronales que se
And
usan para el
then
reconocimiento de
the
imágenes, pues
neural
son
networks that we
las
utilize
redes
to
neuronales
recognize
convolucionales,
images
las cuales pues
are
aplicando
convolutional,
diferentes
which
técnicas,
by
diferentes
applying different techniques
operaciones lógicas y
or
matemáticas,
operations
podemos
of
crear
logic and mathematics, we
kernels
can
que
create
capa tras
kernels
capa, dependiendo de la arquitectura
that layer after
que se
layer
proponga,
of the, depending on the
van reconociendo
architecture that you're
características
proposing,
puntuales de las imágenes, ¿sí?
recognize
Como se ve en
characteristics
el
of
GIF,
the images
podemos ver
of
que
how we can see in this
para hacer
GIF.
una convolución
And
necesitamos
to do a
una especie de
convolutional
kernel
neural
que es
network, we
como,
need a
digamos
specific
que
type of kernel
una especie de
that
técnica o
we
método
can say
para
is a
ir recorriendo
type
píxel
of
por píxel
technique or
o por
method
grupos de
to go
píxeles
pixel by
toda la
pixel
imagen completa
or by
y pues
groups
de
of
ahí ir
pixels the
sacando
whole
patrones
image,
y características.
and then from there
Así se hace pues a
gather
nivel
patterns
clásico.
or characteristics.
Puntualmente,
So this
la
is the
arquitectura de este
classical
modelo es
level.
una
And then
arquitectura
the
UNET,
architecture of this model is a
se llama
unit
así
type,
por la
and it's
forma
called
de la arquitectura.
because of the
A
shape that
diferencia
it
de
takes
otros
on
tipos de
of the
arquitectura, no
architecture.
son
And
capas
differing from other
secuenciales.
types of
En este caso,
architecture, these
pues
are
la
not
primera capa
sequential
está anidada
layers.
con la última
The
capa
first
y
layer
así de forma
is
consecuente.
united with the last layer, and
Este modelo
consequently,
o esta
so on
arquitectura
and so forth.
nos da la
And this
capacidad
model
de
or
poder,
architecture
frente a una
gives us the
imagen de input,
capacity of being able to
generar
take a image
o
input and generate
identificar, ¿sí?
or
Diferentes
identify
patrones puntuales de esa imagen.
different
En este caso,
types of
o la técnica
patterns
que
of
se
that
utiliza es
image, or in this
generando
technique
una
that is
máscara,
utilized,
¿sí? O generando una especie
generating a
de
mask
contraste,
or a
¿sí? Por así decirlo, a nivel
certain type of
funcional. Es
contrast,
que podemos
functional
identificar
contrast,
los
that we
objetos
can
en una imagen para que a
identify
futuro
the
se puedan
objects of an
segmentar de manera
image so
precisa.
that in
Ya vamos
future we
ya
can
vamos a ver
segment them in a more
puntualmente qué
precise
me refiero con el
manner.
tema de las máscaras para que se
And
entienda
what
un
I
poco
mean
mejor.
by the
Pero a grandes
masks,
rasgos,
so that you
esta es la
understand
arquitectura
better, or
clásica
in general
del modelo.
aspects, this is the classical architecture of this model.
También como todos sabemos, a nivel digital,
As we all
tenemos
know, in
obviamente
the
que estos tres canales que
digital
hacen
level,
referencia a los colores
we have these
o
three
que
channels
componen,
that are referencing the colors that
bueno,
compose
básicamente que todos los colores a nivel digital.
all the
Esto es algo
colors
que
in a
también hay que
digital
tenerlo en
manner.
cuenta al momento de
We have to
hacer
keep that in
procesamiento de
mind
imágenes y demás,
when we're
pero
doing a
puntualmente en este
processing of
caso
images.
utilizamos
But in this
imágenes
case, we
de rayos X
utilize
en blanco y negro,
images of
pues
X-rays
obviamente
in black and
para no
white,
darle complejidad tanta complejidad
obviously
al
to not
experimento. Esto
make
quiere
it
decir que acá no
such
utilizamos tres canales,
complex
sino
process.
solamente un canal
But in this
para
case,
representar
we're only
el
using
color
one
en
channel,
blanco y negro.
not three, to represent the black and white
Para poder
colors.
evaluar el modelo a nivel clásico se
To
utilizó
be
esta
able to
métrica,
evaluate the
la
model
métrica
of
DICE o
the
el
classic,
coeficiente del DICE,
we use
que
the DICE
básicamente
metrics,
lo que evalúa es esa
which is essentially
superposición, ese
evaluating
traslapamiento entre
that
la imagen original
superposition or
y
overlap
la
of the
máscara
original image
y esa,
and the mask,
esa métrica, ese detalle de intersección,
and that
digámoslo,
metric or detail
pues
of
nada, nos va
intersectionality
a indicar
will
qué
indicate for
tan
us
performante está nuestro modelo con respecto a las
how
predicciones
this model is
en
performing
datos nuevos y en los datos de
respective to
entrenamiento y
the
de testing,
predictions
¿no?
that we've made of
Otra
the
métrica
model
también a
and the
considerar
data.
para este experimento fue
And another metrics
la
that we can
métrica
consider
de
for this
la
experiment is
intersección over
the
the union, que justamente también
IOU
trata de capturar
that
la diferencia
tries to
entre
capture
las
the
imágenes
difference between
con
the
este
images
coeficiente.
with this
Ambas
coefficient.
métricas van de 0 al 100, siendo
Both metrics
más cercano a 100 la
go
mejor
from 0
métrica
to
para poder
100,
analizar
and the closest to
la
100 is
segmentación
the best
de
metric to be able
diferentes
to
objetos de
analyze the
imágenes, ¿no?
segmentation of different objects in the
Bueno, aquí sí ya
images.
entramos a la parte ya de quantum, ya
Here,
contamos la
we're going
parte clásica.
into the quantum
Justamente
aspect,
nosotros
the
en
class
computación
after the
cuántica,
classic,
para
and
poder
us in
aprovechar
quantum
todos estos fenómenos de la mecánica
computing
cuántica
to be able
y de la
to take
física
advantage
cuántica
of
que nos
these
permiten pues
phenomenons
computar de otra
of
manera,
quantum physics and that
utilizamos
allow us to
propiamente lo que
compute in a
serían ya
different
para estos
manner.
casos
We
algoritmos
utilize
variacionales, ¿sí? Estos
algorithms
algoritmos,
that are
esta familia de
variational
algoritmos
quantum
son las que nos
algorithms.
van a permitir
This
a
family of
nosotros
algorithms permit
en
us
diferentes approaches, ¿sí? Generar o nuevos
different
kernels o
approaches
generar nuevas
to
formas
generate new
de crear
kernels or new
o
ways of
lo que serían
creating
el data embeddings, ¿sí? O generar
the
esa
data embeddings
representación de
or
imágenes a
representing
estados cuánticos
those images
y demás.
in
Esta familia de
quantum
algoritmos es la
states.
que justamente nos
And this
permite
family of
realizar este tipo de
algorithms
operaciones, ¿sí? Y
allows
a
us
nivel
to
técnico van a
make
ver
this
que
type of
inclusive
operation.
en el código ya
And in a technical
cuando
level,
tengan acceso
when
al
the
repo,
coding is
van a ver
done,
que para la creación del
when you
kernel
have access to it, you can see
está
that to create
planteado
the kernel,
justamente
we
con este approach, hacer la
posit
convolución
this
en una
approach
primera capa
to
del
do the
modelo UNET
convolution in a
para
first
que
layer
sirva
of
de
the model
input
unit
a
so that
el
it
modelo
serves us
clásico
as
con sus capas
the
clásicas.
classic
Ahora
model
lo
with
vamos a ver
its
más en detalle,
classic
pero pues
layers.
básicamente
We're going to see this a little in more
las
detail,
herramientas que utilizamos para en este caso
but
crear
the tools that we
un
utilize
kernel
in this case to
con algoritmos
create a
variacionales
kernel
cuánticos fue
with the
con
variational
pero
quantum
obviamente que
algorithms
está
is
abierto a que se utilice
here.
por detrás cualquier
And
tipo
obviously it's open
de
to
SDK
be
basado en
utilized
compuertas universales para
DC
crear este tipo
DK like
de
gates
rotaciones
to be able to create this
de
type of
ansatz para este tipo
rotations
de algoritmos, ¿no? Que
or
nos sirvan de input
ansatz for this type of algorithms
para el procesamiento.
for processing.
Ese término de convolución o convolución
This
cuántica
convolution term or
viene
comes
un paper
from
que salió en el 2019.
a paper that came out in
Y lo pueden ver
2019,
también
and you can
en los
see it
slides y en
as
las
well
referencias
in the
del notebook,
slides and references of the notebook,
donde nos cuenta justamente de
where it
que
tells
a
us
nivel
about
cuántico podemos hacer
on the
o
quantum level,
aprovechar
we can
diferentes
utilize
tipos de
different types of
inicialización de estados para poder encodear
initialization of
datos
states
clásicos.
to be able to
En este caso
code
puntual
classical data.
se muestra en la imagen
In this
de cómo
case,
es la
you can see the
funcionalidad
image of how
de
the
este procesamiento
functionality
de los datos de
of
entrada, en este
this
caso obviamente que una
processing
imagen,
happens
en
of
un
the
kernel,
data. So
donde
the image comes
a
in and
medida
then the
que va
kernel,
pasando el
so that as
procesamiento,
it goes
se
through
va a ir
in processing, you
capturando o
can
vamos a ir encodeando los
recapture
píxeles y su
or code
representación
all the
en
pixels
estados
and their
cuánticos, ¿sí?
representation in different quantum
Obviamente que ya
states.
a nivel funcional vamos a ver que
In a functional way,
el dataset original, que son
we see that
que
the
son las imágenes
original data set
pues
that are the
de rayos X de
images
pulmones, ¿sí?
of
Vamos a ver
X-rays
que
of lungs,
el acto de
we see
procesar esas
that
imágenes
the act
con
of processing these
computación
images
cuántica o con circuitos
with quantum
variacionales
computing or
nos dan como resultado
variational
este tipo
circuits give us as a result this type
de imagen, ¿sí?
of image.
Para este caso, como les mencionaba,
In this
para
case,
que un
as I
modelo
was
pueda
mentioning,
segmentar, hay
so
que
that a model
entrenarlo
can be
con las
segmented,
imágenes
we have to train
generales,
it
¿sí?
against the
Y de
images
estas
of the
imágenes
general
generales
image.
sacar una
And from
especie
these
de
general
contraste o
images,
máscara
we
del
get
objeto que
some
queremos
sort of a contrast or
identificar.
mask of
Entonces, en este
the
caso,
object that we want to
se puede
identify.
apreciar que al
So
lado
in this
izquierdo
case, we can appreciate
tenemos
that
lo
on the
que es
left,
la
we
representación de una
have
imagen de todo ese set
the
de datos,
representation
de
of
las
an
máscaras.
image of
Esta
all
sería la
that data
máscara
set
de
of
un
the
pulmón,
masks.
justamente pues de
This is
esta
the mask
imagen.
of a lung,
Y
and
este es
exactly
el
from this
resultado de haber
image over here.
procesado
And this is the result of having
justamente
processed
con la técnica que mencionamos
this with
de
this
la
technique
convolución,
that I
¿sí?
mentioned before of convolution.
Los resultados de este experimento
The
nos
results of
dieron
this experiment gave
los
us
siguientes. El modelo se entrenó con
the
30 épocas.
following
Esas 30
evolutions with
épocas se
30
analizó el coeficiente del
epochs,
DICE, que básicamente esa va a ser la
and
métrica
we
de
analyzed the
referencia
coefficient
para
of the
saber qué
dice
tan
as a
bueno está
reference
segmentando el
to be
modelo
able
o
to
no.
know how well is this
Estos
model
fueron los
segmenting or
resultados
not. And these were the
de los
results
datos de testing de
of the
las
data that
141 imágenes
of the testing of
de
the
testeo. En
141
este caso
images
es
that
las
were tested.
141 imágenes,
In this
la
case,
distribución del coeficiente DICE.
141
Podemos ver
images
que
of this coefficient dice.
aproximadamente todas las
We
imágenes
can
de
see
test
that
están casi que
approximately
de
all
un
the
0,8
test
en
images
adelante, o sea, es un
are
dato
in
bueno.
0.8.
Si vamos a ver
So
ya
it's a
los
good data.
resultados ya a nivel real
But if we look at
de
the
las
real
predicciones
results
con
from
respecto a
the
una máscara
prediction
real y demás, pues vamos
versus
a
the
ver que
real
el
mask,
coeficiente DICE, que es esa
we
superposición,
see that the
se
dice
puede apreciar
coefficient,
que
which is the
pues
superposition,
no está tan,
we can appreciate that it's
digamos,
not as
performante con respecto a la foto de de los
performing
pulmones reales, ¿no?
versus the image of the real
Em,
lungs.
Este experimento también se hizo de dos
So
formas.
this experiment was
Obviamente
also
que
done in
una
two
para
ways.
economizar recursos y
One was
demás
for
fue crear el QNOW o
economizing
crear la
resources.
capa
So they
que
created the
golpea
Q
nuestro
note or the
circuito
layer
cuántico con solamente un
that
shot cada vez que
groups our
procesaba
quantum
nuestro
circuit.
circuito cuántico, ¿sí? El
Each
resultado
time that our quantum
de ese
circuit was
experimento fue
processing,
procesar las
the
imágenes
result of the
ya no
experiment was
de esta
processing the
calidad como
images,
se aprecia acá,
not in
sino
this
ya como un
quality
poco
as we
pues
can
más
appreciate here,
de
but
distorsión o más
more
de ruido, digámoslo
with a
así,
little
en
bit
la
of
imagen,
distortion
¿sí?
or
Y
noise
el
in the
resultado de
image.
haber
And the
segmentado los pulmones
result
con estas
then
imágenes
by
de un solo
segmenting the
shot,
lungs with those images
pues
of
nos
one
dio
single shot
este resultado,
gave
¿sí?
us
A
this type of
comparación
result.
de haber procesado
In
las imágenes
comparison
con
of having processed the
1024 shots
images
como,
with
como mínimo
1,024
en todo el
shots
proceso
as a
de
minimum,
nuestro algoritmo.
the whole process of
Estos
our
fueron los
algorithm,
resultados que pues con
these were the
respecto a lo clásico,
results.
pues obviamente que lo clásico sigue
And
siendo más eficiente,
respecting the
pero
classical
como les
image,
comentaba al
which is more
principio,
efficient, as I
en
was
software pues no
mentioning
estamos
in the
limitados
beginning, in software,
diseñar
we're
o
not
a
as
poder
limited
jugar y probar
to
este tipo de
design or be able to
aplicaciones.
play with this type of
Estos fueron los
application.
resultados ya pues con
These are the
más
results that
shots.
we
¿Sí?
obtained with
¿Qué
more shots.
desafíos o qué
What were the challenges
cosas a tener en cuenta
that
para
we have to
experimentos futuros
keep
y
in
demás
mind
tenemos por acá?
for this and future
Como les
experiments that
mencionaba,
we might do?
para evitar
As I was
o
mentioning
para
before,
hacer
to
más eficientes los
avoid
experimentos,
or
el
make more
approach
efficient these
que utilizamos
experiments,
acá
the
y que
approach that
también
we
se
used
utiliza
here
en Penny Lane,
and
que
that
es
was
la
also
referencia de
utilized
la
in
convolución,
Penny Lane, which
es
is a reference of the
justamente
convolution,
en modelos o en
is
diferentes arquitecturas
exactly
clásicas,
that in models or
crear esa
classical
capa
architectures,
de encoding
we create that
cuántico al
layer
principio del modelo
of
clásico para
colink
que el modelo
quantic
clásico aprenda de
of
los
the classic
datos
model,
que se
so that the
generaron
classic model
como
then learns
resultado de un
from the
proceso
data
cuántico.
that is
¿Sí?
generated as a
Pero
result of the quantum
obviamente
process.
que hay diferentes
But of
approaches
course,
en los cuales no
there's
solamente
different
la capa
approaches
cuántica que nosotros
that not only the
queremos
quantum
hacer uso
layer
se pone al
that we
principio de la
generate
arquitectura,
or want to
sino también
utilize
un
can be
desafío
put
está
at the
en
beginning
poner
of the
esa capa
architecture, but
cuántica
it's also
en
a
el
challenge
medio
to use
de la
that
arquitectura y generar
quantum
diferentes capas
layer in the
y que
middle
nuestro
of the
modelo pues sea
architecture and
un
generate
modelo
different
híbrido, por así
layers
decirlo. ¿Qué
to
pasa?
create
Obviamente que
a
esto va a
hybrid model.
aumentar el tiempo de
Obviously, this will
procesamiento y de
also
entrenamiento
increase the time that
pues
the processing
propiamente
takes
de los
place,
modelos, ¿sí?
and of
Otro
course of
desafío que
these
hay
models.
es justamente
Another
hacer
challenge
pruebas
is
con
exactly
kernels
how
de
to
mayor
make
tamaño, ¿sí? O kernels
trials or tests with
que nos
kernels that are
permitan
a
usar
larger size or
y
kernels that
hacer
allow
pruebas
us to
con
utilize
procesamientos utilizando más qubits.
or do
En nuestro caso,
trials
pues sí
with more
estamos
qubits.
limitados, ya que pues obviamente
So
que
we
en
are
este
a bit
experimento se
limited
utiliza un kernel
because
solamente
in
de
this
4
experiment
qubits.
we used kernels
Estamos
of
limitados
only 4 qubits, and
justamente
we're
si
limited
queremos hacer que ese
if we
kernel
want to
crezca
make this
a igual
kernel
tamaño de la
to
imagen, porque no,
grow
hay que ver
to
ese tipo
the
de
same size
experimentos.
of the image, because we
Pero
don't have one like
al
that
usar
in
más
this type of experiments.
o
But if we
o al
use
hacer
more
uso
than
de imágenes de más de
or make
20
use
por
of
20, ya nos quedamos
images that
cortos a
have
nivel de
more
hardware,
than 20 by
pues
20,
por lo menos con los hardware que
we
tenemos hoy
run
en día para
short
hacer
on
uso
hardware, at least in the
ese
hardware that
cómputo,
we
¿no?
currently have
Em,
available for this
En
computing.
este caso, las imágenes que se
In
entrenaron
this case,
fueron de
the images
256 por
that were trained
256,
were
como les mencionaba, con el kernel
256 by
de 4 qubits
256
o de 4
with the
píxeles,
kernel of
¿sí?
4 qubits or 4
Em,
pixels.
se sabe que a nivel clásico, pues los
So
kernels
we
de
know that
más
on a
baja
classical level, the
dimensionalidad,
kernels that
digamos,
are lower
de más
dimensionality
bajo o que se hagan con menos
or that are
o
done
kernels
with
chicos,
less
tienen más
or
aprovechamiento de los
smaller
datos
kernels
a nivel local,
um,
¿sí? A medida que se va
take more
realizando la
advantage
operación
of
de las
the data
convoluciones,
that's
pero pues
done
también la
on
puerta
a
está abierta a
local
probar
level
con
with the
kernels
convolutions utilized. But of course, we
de
can try
mayor
with kernels that
escala,
are
¿no?
of a bigger
Otros
scale.
desafíos también que hay justamente
A few other challenges that we have
son utilizar
are
o correr ya este experimento en una computadora
running this
cuántica
experiment
real.
in a real
Por ahora el
quantum
experimento se
computer.
corrió simplemente en
Right
un
now,
simulador.
we did
Por
the results
defecto
in a simulator
utilizamos el simulador
because of
de Penny Lane. También queda
we
abierto
use the
y
Penny
se
Lane
puede solamente
simulator,
cambiando una
and
línea de
it's
código e
open and we
instalando
can
los plugins
change one line of
de
code
Qiskit
and do the
sobre Penny Lane para
Qiskit
hacer uso de los backends
plugins
de
over
IBM y
Penny
demás.
Lane to use the backends
Em,
of IBM
Otro
and
desafío
so on.
sería correr este
Another
mismo experimento,
challenge
pero en
would
diferente
also be
hardware,
run the same experiment
ya
in
sea
a
en
different
hardware
hardware.
basado en fotones o en trampa de
That
iones
could
para
be
también ver
photon
los
based
resultados de
to see
cómo
the
performa el
results
modelo y
of
de poder
how it
comparar las
performs
métricas
the model
clásicas con las
and be able
cuánticas
to
y
compare
poder
the metric of
tener un
classic
benchmark
metrics with
pues
the quantum
adecuado,
ones
¿sí?
and have a benchmark to adequately
Y
measure
pues ya como
against.
tal, otro desafío grande
And
está en
another
poder
challenge we saw that was really
anidar
great
este proceso de
was being able
segmentación a nivel
to
cuántico con lo que también mencionábamos al principio,
take the
los
quantum
procesos más grandes,
process with
¿sí?
the initial processes that are
Diagnóstico de
larger
cáncer y demás en lo
of
que serían
diagnosis of
pulmones.
cancer and others
Las
in the
herramientas que se
lungs.
utilizaron en este
The
experimento
tools that we
fueron
utilized
todo
in this
material open
experiment were
source,
Python. They
justamente
were all
con
open
Penny Lane,
source with Penny
la notebook
Lane,
clásica se sacó de Kaggle,
The
el
classic
entrenamiento se hizo en
notebook
Colab
of
y también en
Kaggle,
servidores propios,
the training was done
pero
in
bueno,
Colab,
se va a poder mejor ver
but
en
of
el
course,
notebook.
you could see this better in the
Hasta aquí esa
notebook.
parte
And so on
de contextualización y
up to
conceptos.
here, this is the
Y bueno, si hay algunas preguntas,
contextualization and
se
concepts,
pueden
and if
responder
there's
ahora.
any questions, I can happily take them.
Muchas gracias, Daniel. Excelente. Thank you very much, Daniel. This was an excellent presentation, and I was very much looking forward to it, especially because it illustrates a lot of the topics that we have been covering throughout the program. VQE was covered last week, and I think that one of the goals was for us to be able to support the learning and give the opportunity that if they want to read research that comes from different companies or different papers, that they can understand a little bit of the context of the algorithms that are being created. So I do have some feedback and a question from the Discord channel. It says, actually, Ayelen, I'm going to ask you to unmute so you can read the question in Spanish. I can find you here.
Perfecto, ahí
Ya
la leo.
estás. Adelante, léela.
Sí.
This way go ahead.
Ahí, Dani pregunta, primero menciona, excelente presentación. Tenía la consulta de en qué parte del proceso se utilizaba
Excellent
la segmentación
presentation. I
cuántica.
had a
Pero
question
lo
of
que entiendo,
when do
existe
you
la
use the
posibilidad de
quantum
usarla tanto al inicio
segmentation,
como en medio de
and
la red neuronal,
as you can
¿verdad?
utilize it at the beginning
Tal
or
cual,
in
tal
the
cual.
middle of the
Em,
process. Of course,
el approach acá fue justamente
the
al
approach
inicio
here
de
was
todo el,
at the beginning of
justamente acá,
all of
este es
this
el modelo clásico, esta es la
right
arquitectura del
here
modelo
of
clásico,
the classic
pero
model.
nosotros lo que hicimos y también lo que está justamente
But what we did here,
en el artículo
and
de Penny Lane, es
exactly here in the Penny Lane article, we
procesar todas las
segmented,
imágenes de entrenamiento
we
de este modelo
processed all the
clásico,
images of the
pero de
training
manera
in
cuántica.
this
Ese fue el
classical model,
approach acá.
but in a
El desafío está
quantum way.
justamente
This was the
en
approach that we took. The
generar o
challenge
crear
was
o diseñar
exactly
arquitecturas
in being able to
donde
generate
tenga
or create
capaz en la mitad
architectures in which
de forma
we
cuántica.
could
Ahí es donde está el desafío y estaría muy
midway
bueno
through
ver
do the
ese tipo de
quantum
experimentos o de
technique, and
acercamientos.
this is the type of experiment that we would like to see more of.
That makes a lot of sense. I think we're all looking for the technology to evolve to that point, and they're saying perfect. Thank you very much. Okay, any other questions for Daniel? We're doing really good on time, so if you have questions about how he did it, any refinements specifically, go ahead and ask. Otherwise, you can ask, and then we can work with him to get you answers after the presentation. Okay. Okay. So I have a question for you. How much time, I mean, did you how long did it take to run in the hardware? Was it
Sí, bueno, en los experimentos utilicé
Yes, in the experiments, I
dos hardware,
utilized
digamos. Utilicé
two
el
hardwares,
simulador con
let's say.
GPU que tiene Penny Lane, que
I
también en el
used
código
the GPU simulator in
lo pueden
Penny
llegar
Lane
a ver.
that you can see the
Y
coding
con
in the
con la
notebook.
GPU fue un
And with the
poco
GPU,
medio lento
it
al
was a bit
principio. Y te
slow
podría
at the
decir que
beginning.
tuve que cancelar el
And I can tell
procesamiento
you that I had to
pasadas 4
cancel the
horas porque
processing
no veía tantos
after 4
avances.
hours because I
Cambié
wasn't
a
seeing
utilizar el
much
procesador, un CPU, ¿sí? Con el default
progress, so
qubit,
I
que
changed
es
it
el
to a
backend que por
CPU
defecto te
processor,
permite Penny Lane. Y se
which
tardó
is the
casi que
backend
6
queue that
horas procesando
Penny Lane permits, and it took about 6
800
hours
imágenes,
to process
que en este caso
the
serían
800 images that in this
las imágenes,
case
las máscaras y las
were
imágenes de rayos
the
X
masks and the
del
X-ray
pulmón.
images
Eso fue lo que
of the
tardó
lung.
el experimento.
That's what took
Si lo
as
tuviéramos que
that's how
correr en
long the
una
experiment
computadora
took. And
cuántica
if we
real,
had to run it in a computer
no
that
sé
were
si
a
IBM nos
quantum computer,
dejaría tanto tiempo
I don't know if
esperando
IBM would let
en
us
su queue,
have so much time waiting in
pero
their
en cuánto
queue,
tiempo eso fue lo que se demoró aproximadamente.
but that was
Excelente,
approximately
muchas
how
gracias.
much it took to do
Thank you very
this.
much. That's really good
Thank you very much.
context for folks to know that, you know, about 6 hours and it's different in different hard, but that's good because that also is investment when you are running in hardware and you are sponsoring it yourself. So it's good to kind of have a baseline of understanding if there is a way that you can calculate it. All right, then thank you so much, Daniel, and we really appreciate your time and sharing everything. To all our participants, I have placed this now, both his presentation and the code book in our week 4 folder, so you'll be able to check that out and reach out in Discord if you have additional questions. All right. So
Genial, muchas gracias.
gracias a usted, muchísimas gracias. All right, so we are going to shift into, as you all know, we have different challenges, and one of them was the humanitarian challenge. The humanitarian challenge asked you to look at the world around you and really imagine yourself in a situation where you had unlimited resources of health, wealth, time. Time is a very important, very critical resource. Never underestimate where you invest your time. And it asks you from a position of the ability to solve anything with no imagined, perceived, or real limitations. What would you fix? What would you fix in the world that you have observed? And so there were several submissions. I want to share with you Dr. Assaf's presentation because it is something that right now in the NIH challenge, for example, I mean, we all know that everyone's ideas are proprietary, right? So it's not like, which is why we said, run with your idea, make it public, find some friends and apply. The knowledge you have right now could help you like really submit to some of these things. So Dr. Assaf, when you are ready, you can share your screen and I'm going to ask you to walk us through one of your proposals for research in the medical field and quantum. Go right ahead.
All right, thank you so much.
Oh, wait, actually, I forgot to present you because I know you. It's just my bad. Let me do that and then I will. Okay. So, Karime Assaf is a medical doctor graduated from Universidad Iberoamericana, UNIBE. Her passion for research led her to Speratum, where she worked on preclinical oncological studies, and later to the UNC Center for Health Promotion and Disease Prevention. Focusing on nutrition and lifestyle research, she's committed to health equity and integrative medicine. She aims to integrate both her clinical practice and expand her research. So I'm going to stop sharing. You can go ahead and share and let me know if you're running into any issues. You should be able to do that.
Okay, wonderful. Well, good evening, everybody. Thank you so much for having me. I just wanted to give you guys a little bit of context. I've been partially a co-organizer of the event, and I had absolutely no idea what Python or quantum was. So this was a very different field for me. And I'm here to talk about my idea for the humanitarian challenge. So I wanted to talk about the application of quantum algorithms in next generation sequencing in regards to pancreatic cancer with tumor samples and how that could potentially customize chemotherapy. So let's talk a little bit about where the pancreas is. Basically, it's a retroperitoneal organ. That means it's behind and under your stomach and a bunch of other things, your colon. So it's really kind of hard to access it. And in the body, we don't really see symptoms unless something is going on. So that means that unless it gets to a point where it's really causing problems, we're not going to see any symptoms. The incidence of pancreatic cancer is about 13.5 in 100,000 people. It's the second cause of cancer-related deaths in the world, and the survival rate actually went up. Before last year, it was about 10%. 2024 is 13%. But basically, life expectancy is less than 5 years. And this is related to the fact that we don't have diagnostic or screening tools for this. Again, location is really important. There aren't specific biomarkers related to this type of cancer. So we find it in typically stage 3 or 4. So the treatment for this type of cancer is surgery. However, because there's a later detection, this usually means that the patients are ineligible for surgery. And chemotherapy is generic. So if you have an infection in your body, typically they'll give kind of like empiric or generic antibiotics. It's just kind of like, let's see if we can just, shoot our shot and see if it hits something that can potentially help the evolution of the disease. However, it's not specific, and often these tumors develop resistance. So in the space of genomic medicine, there is next generation sequencing. So basically, it's a way of looking at our DNA or looking at the code of our DNA and seeing what mutations arise from this tumor that has developed. So then we transition into genomic profiling, and there's different ways of doing this. So there's somatic mutations which basically arise in the tumor but are not really inherited. Then there's ways that you can amplify the genes or delete the genes, and every cancer basically has different evolution. So that's another way. And then we have chromosomal rearrangements, which is basically structural issues. But we can see exactly how these mutations can develop with genomic profiling. In next generation sequencing, there are specific mutations. Typically, the ones that you'll see are KRAS, TP53, and all of these are usually seen. So, like KRAS is usually seen in colon cancer. I don't know if you guys have heard of like BRCA, or usually people say, oh, Angelina Jolie, for example, had breast cancer. They found this her mutation, and so she decided to prophylactically get a mastectomy. So basically, that's where this comes from. And if we're able to identify the driving mutations, then that means that we could potentially identify the type of treatment. Now, the mutations around the tumor are different than the environment inside the tumor. So I don't know, imagine you have like a moon pie and you have different mutations on the outside, and then the stuffing of the moon pie is different. And obviously it's a different texture, and there's so many different things going on. So if we were able to obtain samples, not only like from the outside, kind of like all the way through, we could see the difference in the mutations on the outside and the inside, and therefore see why we have certain resistance to specific chemotherapies. So my idea was, what if we applied quantum computing to the next generation sequencing that determines the genomic profile of the tumor in samples with patients with pancreatic cancer? Next generation sequencing takes, if it's a specific sequence, it can take a couple of hours. But if you're doing a full profile, it can take up to 10 days. So if we were able to get faster results, then we would allow oncologists to be able to customize chemotherapy and then lead into more precision medicine. So a couple of things that could be used is quantum approximate optimization algorithm, which is basically identifying the optimal gene expression and profile and finding the best alignment of sequences. It's just another way of seeing how quickly we could identify the molecular docking and then potentially design synthetic DNA sequences with specific properties. So if we wanted to find a specific mutation and see how that develops, that is something that we could do. Then quantum annealing for sequence alignment. So sequence alignment and fundamental task in next generation sequencing basically is like aligning the short ends of the DNA strands to read and reference a specific genome. Particularly with devices like D-Wave Quantum Annealer, could potentially be used to find optimal alignments. Again, remember, genomes are sequences, so it's just like lines and the way that the computer would be able to read it. And again, the idea would be tailor specific chemotherapy to the patients and then potentially improve the survival rate. Now, another idea that I had was if we could work backwards and see what mutations occurred, then maybe we could find specific biomarkers and then find a diagnostic tool. So that's something else that there's currently research in, working with saliva and feces and urine to see if there's anything in the biomarkers of these patients. But basically, the idea is quantum and precision medicine and finding exactly what aligns for the patient's needs. Thank you so much for your time. I really appreciate it. If you have any questions, please let me know.
Thank you, Karime. If you have any questions, you can add them in the Discord channel. You can add them in the chat. And then we will ask Dr. Assaf. For obvious reasons, she is not winning any prizes, you know, because that would be cool. But I really want you to know that we had incredibly inspiring propositions and submissions, and I think that there's value in sharing your ideas, and if there is interest in that, we can hold some things separately, because like I'm telling you, the first stage, for example, of these challenges, you could win $10,000. That could make a difference. I win nothing by telling you this. I just want you to feel motivated to learn more, inspired to kind of find more information, meet people. And one of the things that we wanted to do with this program was talk to you about quantum for good. So we got together and we spoke to some of our amazing interns and organizers, and we said, what does looking at revolutionizing medicine and healing, a personal passion of mine is to bring the latest research in both medical and technological advancements to everyone. The ability to get better should not be limited by our income. It just goes against my values in that sense. So what if you put the knowledge and the access in the hands of everyone? So that is one of the great drivers as to why we do what we do. So Grazia, are you on? I think I saw you on the line. If you could turn on your camera. I am going to, are you here, Grazia? There you are. Okay, if you'd like to turn on your camera, that'd be great. So Grazia was helping us lead this track within the interns, and so she developed this notebook. So just like Karime, she talks about different things, and her perspective is quantum machine learning and drug discovery. So one of the areas that this NIH prize event is looking for. You know, we have X Prize for $5 million sponsored by Google, and this other competition is National Institute of Health in the USA, sponsored by the challenges.gov. So they're looking into drug discovery, prediction, like what Karime and Danielle spoke to you about. They're also looking into that. So she has this really awesome notebook, and just take a look at it. It's going to be in week 4. It runs you through different exercises. And for those of you that came to our event where Fabian presented the Python notebook, you know, you'll be able to see here. Most of you know what Qiskit AER is, the simulator. It makes me really happy that we go from baseline, and now you can read these things and be able to understand them. So check out this notebook. And Grazia, is there anything you would like to share with them? Did you were you able to turn on your camera? No? Okay, no problem. So oh, there she is.
Yeah.
I just want to give her a spotlight here, so you can see her. And she is also an does research, data science and epidemiology, and she has been amazing at leading this stream. So reach out to her, make some connections, and I don't know if Fabian was on the line, but he also did the presentation the other day on Python, which if you're doing any work on data science or you are curious, it is the best hour invested. I did my best to translate. I'm not as great as Shireen in that sense, but honestly, you have the benefit of the work of so many brilliant interns. So very well. So Grazia or Fabian, just make sure you're here later. And Johan, I think I'm going to ask you to unmute. I'm going to do the introduction. Oh, there's Fabian. Hello. Awesome.
Hello.
All right. So, Johan, you can, okay, you're ready. So I'm going to introduce our next speaker. We're going to go, he sent us a recording because it is incredibly late where he is. And I think you're going to write like kind of the retro way that he presents his video. So I'm going to introduce him now. I think it's this way. So Mariano Caruso is also a member of Q Now. I think he is, let me talk you through what he is going to present. Quantum inspiration from analog devices. So Mariano is a quantum computing researcher with a PhD from UGR. He's specializing in variational formulation of stochastic processes. As the coordinator of the Quantum Unit at Fidesol and professor in the Quantum Computing Master's Program at UNID, in case any of you are considering pursuing a master's program, you know who to reach out to, combines quantum theories and machine learning, provides consultancy to companies developing products and services based on the latest fundamental research in quantum computing, promotes collaboration between academia and industry, standing out of the intersection of computational science and quantum research. Its research encompasses machine learning and its secure methodologies using both classical and quantum techniques. I'm going to stop sharing. Johan is going to share his screen and then play the video. While he sets that up, I'm just going to share with you that it is different times in terms of funding, and depending on where you are in the world, you might normally be used to grants, but I'm seeing a shift in some of the opportunities that are coming out, and that has to do with the ability to work on research despite not being in academia. Some of those processes that have been historically very regimented are changing. So just keep that in mind and know that I will be sharing the links for these competitions. So if you feel like you want to do it, please go ahead and do so. Adelante, Johan. Hit play. No lo escucho, but let's see.
Wait for it.
Okay, cool.
Muy buenas. ¿Qué tal?
Okay, let me see. Okay. I'm not hearing it also.
I can hear it now.
You can hear it?
De esta extraordinaria, impactante, quizá, presentación llena de efectos especiales, vamos a comenzar
You can hear
con
it?
una sesión
I
de
can
hoy.
hear it, but kind of in an
There's
echo.
echo.
Se darán cuenta,
Okay, let me see.
la cantidad de ediciones,
Tendrías
Hold
que
on.
mutearte,
efectos
Johan,
especiales
y
previas,
creo que se escucharía bien.
habrán alucinado justamente con esto, se darán cuenta de que está grabada esta sesión. Y en principio, lo primero de todo es pedirles disculpas por no poder estar ahí, por no poder recibir preguntas, sugerencias o dudas, algún insulto, etcétera.
Johan,
También agradecer a la organización
Can you
justamente
hear it?
del Qiskit
We
Fall,
can hear it,
todo lo que
but
rodea
it is
este evento,
playing like in an
de los
echo.
co-coordinadores también.
Okay, let me see. What's going on?
Ayelen, do you? Let me see if I can.
Shrin
Sorry,
nos
folks. Technical
recomienda.
difficulties.
Yeah.
We're trying multi-languages and recordings. Hold on. Okay, let's try this
Dos países y
again,
demás.
and if
Es
not,
la verdad que una alegría poder
Can you hear it now?
Nope.
hablar a
Oh,
toda esta comunidad también latinoamericana.
Restart,
Y
por
que
favor.
escuche este
it's
video a
very
posteriori.
echoed.
Restart.
Para interesarse por los temas de computación cuántica o de tecnologías cuánticas.
Okay, you can pause it and let's I'm going to see if I could do it. Ayelen, are you able to do it if mine shows up laggy?
En general,
Sí,
Since
por supuesto.
your language is in Spanish?
I'm on it.
Okay. I'm gonna
Ahí
move this
estoy.
over here. Sorry, two screens, folks. See how quickly we can
Is
pivot.
Ayelen going to share it or?
Yep.
Okay.
Okay, go for it,
Denme
Ayelen.
un
Thank you.
segundo.
Sorry.
No, that's okay, Johan. I tried it with the other one. That's why it happened to me also. It just wasn't sounding right. So thank you for giving a
I
chance.
I can share. No me aparece para compartir. Acá.
Okay, in your language is
Bien.
set to Spanish, right, Ayelen?
Sí,
Yes. Okay.
está en español. Ahí pueden ver mi pantalla.
Mhm.
Perfecto. Díganme si pueden escucharlo bien.
bueno, muy buenas. ¿Qué tal? Después de esta extraordinaria, impactante quizá, presentación
Hello.
llena de efectos
After
especiales,
this
vamos a comenzar con esta
impactful
sesión de hoy.
presentation,
Yes.
Como se darán cuenta, justamente
as
por
you can
la
see,
cantidad de ediciones en efectos especiales previa que habrán
with the
alucinado
type
justamente
of
con esto,
special
se darán cuenta de
effects
que está
that we
grabada
have with
esta
this,
sesión. Y en principio,
we
lo
have
primero de
taped
todo
this
es
session.
pedirles
First of
disculpas por
all,
no poder estar ahí, por no poder recibir
I apologize
preguntas,
for not being able to
sugerencias
be
o
there
dudas, algún
and
insulto,
to be able to
etcétera.
receive your questions or
También
suggestions
agradecer a la
or any
organización
insults.
justamente del
I would like
francés,
to
de todo lo que rodea
appreciate
este evento,
the organization
de los co-coordinadores
that
también de
have
los
put
distintos
on this
países y
event,
demás.
of the
Es la verdad que una alegría
co-coordinators,
poder
organizers,
hablar a
and
esta
I'm
comunidad
happy
también
to talk about
latinoamericana y quien escuche este video a
the
posteriori.
Latin American community
Para interesarse por estos temas de computación computación cuántica o de tecnologías cuánticas en
And
general.
because you're
Esto es lo que
interested in the
hago.
quantum computing
Y en principio lo quiero hacer
topic,
bastante rápido, pero no quiero dejar
and
de hacer
in
esta
principle, I
introducción.
want to do this
Con
quickly,
eso me presento. Mi
but
nombre es
also give an
Mariano
introduction.
y
My name is Mariano
originalmente vengo
Caruso,
de Argentina. Por
and
resumir
as you can see, I'm from Argentina.
brevísimamente, para que se entienda un poco también los motivos de por qué hablar de estos temas,
And
por qué
as well,
presentar
so that
nuestra
you can
institución,
understand the motives or
objetivo,
the
etcétera,
theme
van a entrar de lleno directamente con el título de la sesión, que
to
es justamente lo que estamos viendo
enter
ahora.
with the title of our session.
Y ahí ya pueden ver algunos logos y voy a empezar a explicar un poco brevemente
And
por
as
esto y
you can
empezamos
see, there's
a
some
la sesión
logos,
como tal. Por
and we'll
empezar y
start
para
the
que se
session.
entienda, de formación,
To start
comencé ya en la escuela secundaria con
my formation
electrónica. Hay una modalidad en Argentina de escuela
was
industrial, en
electronic
la
technique
Chaparral, ¿sí? Ahí es donde fui. Después
in El
pasé
Chaparral
a
School,
ingeniería electrónica en la UTN, en
and then
Argentina, en
I
la
went to
universidad.
electronic engineering,
Y empecé ingeniería electrónica, pero me arrepentí. A la mitad de
and I
4 años,
started
de los
in
6 años que
electronic
tenía en la carrera,
engineering.
cambié a física.
But of
¿sí?
the
Porque
6
realmente
years of the
no
career, in
conocía
the
ni siquiera
4th year, I
existía la carrera de
changed.
física como tal. Mala prensa en esa
And I
época.
didn't know about the
Y
career
creo
of
que ahora,
physics.
bueno, puede ser que tenga un poco de mejor prensa. Después de haber hecho la carrera ahí sí completa, no en la versión demo
After
como con la ingeniería,
done my full
terminé la
career of
licenciatura
6
en La
years,
Plata, en la Universidad de La Plata, y
I
pude hacer el doctorado
finished my
después acá
bachelor's in the
para mi
Universidad de La
colegio.
Plata,
Pero lo
and I
importante es que
went
por
to,
eso lo cuento. Y después, bueno, el postdoc fue en un grupo de
and
investigación
that's why I'm telling you,
con otro tema que nada que ver, un grupo
the type of
excelente de
other
ingenieros también,
investigations, other areas,
algún matemático también, que
of
justamente
course,
se
some
dedicaban a
math as
tocar
well,
otro tema de la física y de la ingeniería, que son los medios continuos.
and a few themes of
Esencialmente,
physics
una de
and
las cosas que estuve
engineering.
trabajando yo, más en la parte teórica, pero es
Some of the things that
lo
I'm
que hacían en
working
ese
on
grupo, entre
are
otras
quantum,
cosas, es trabajar
but I
cómo
was part of this
poder
group
tratar cierto tipo de
to
cánceres, por
work
ejemplo, irradiando ondas de
how to
visión al
treat
tejido.
certain types of
Bueno, en
cancer
fin, temas muy
and
variados.
in the tissue,
¿Qué quiero decir con todo esto y por qué lo
several
cuento?
different
No
topics.
para tirarme ningún
So
tipo
what
de
am I
flores ni nada,
sharing
simplemente para
about
que se
this with
entienda
you?
que carreras
It's so that you understand that
accidentales o
careers,
extrañas, sinuosas, etcétera,
accidental
pueden
careers
darle
or
de
very
vuelta
varied,
y
can give you a way
justamente a
to
retomar a estos temas de física. Parte de mi
of
trabajo de
retaking some of these
licenciatura en Argentina fueron
physics
sobre cuántica
themes.
y sobre
I
unas
didn't
simulaciones
study about
justamente. Y de eso
quantics,
vamos a hablar,
quantum
entre otras cosas,
or
hoy. ¿sí?
simulations, but we're going to
Em,
talk about some
¿Qué
of
más?
these.
Entonces, paso a comentar
What
básicamente los
else?
logos que ven por ahí.
So
Quorum, como ven por
I'm
ahí, es
telling
un
you a few about the
proyecto
logos that
que
you
nos
see
acaban
here.
de conceder recientemente. ¿sí?
Some of the projects are
Y
quorum
están todas
that
estas
we just got
entidades.
granted.
Yo estoy
And then there's
trabajando
all
en
these different
Fidesol,
entities here
que es un
that I'm
centro tecnológico.
working in
Y también,
Fidesol,
bueno, haciendo colaboraciones con muchas
and
otras
also
empresas
collaborations
y
with other
centros y grupos de investigación.
businesses
En particular, en
and
este proyecto de
investigation
Quorum,
groups. And
nuclea,
in
digamos,
this
varias
project of
entidades de
quorum,
distintos tipos. No hay empresas como tal solamente,
several
sino
different
tenés
entities of
Gradiant,
different
que es un centro
types are there,
tecnológico, como
like
Fidesol,
Gradient
como ITECAM, ¿sí?
and
Estos centros
Fidesol
tecnológicos
and
son, en
ITECAM
rigor de verdad, son fundaciones en España, ¿sí? Funcionan con
are
ese
meteorological
formato, digamos.
with functions
La Junta de
of this
Galicia,
format. Junta de Galicia
Fujitsu, la empresa, el SEGA, que es un centro de
and
supercomputación, y una
Fujitsu is a
empresa
company,
española que también puse en chat,
SESGA, and
que tiene
another
una
company
plataforma
called
con
ITECAM and Centroid
algoritmos clásicos y
that
cuánticos
has a
que, bueno,
platform
uno va con un problema bien
with
formulado o no,
classical and quantum
y puede
problems
conectar
that are
con todos los
formulated
proveedores de hardware que
and
tengan disponibles
connect
para
with all kind of
resolverlos con
providers
computación clásica,
that are
híbrida,
available to
etcétera,
solve
¿sí?
these
Y
classical
cuántica.
and hybrid
Bien, entonces,
and quantum problems. So,
con todo esto, voy a contar
therefore,
justamente algunas
with all
ideas
this, what I'm telling
sobre
you is a
esto
few
justamente,
ideas
que esencialmente
about
lo que intenta acá es
quantum
motivar,
inspiration
porque
from
la palabra
analog
inspiración hay,
devices.
no sé si ustedes conocen, pero
Because
seguramente sí,
the word
lo que se llaman
inspiration
algoritmos de inspiración cuántica, ¿sí? Esencialmente son
are algorithms
algoritmos
of
que
quantum
se pueden ejecutar
inspiration
en máquinas clásicas, como
that
tal,
can be
por
executed
ejemplo,
in classical
que toman
machines,
inspiración, que se
for
motivan con
example,
determinados
and
fenómenos,
take
determinadas
inspiration or are motivated
situaciones que hay
through
en la
certain
cuántica, y las
phenoms
pueden tomar
or
para
situations that are in
implementar,
quantum and can
para
be
resolver un
taken
problema
to be
de
implemented
manera más eficiente, o
to
sea, todo lo
solve a
que se
problem,
pretende hacer, pero toman idea de la
to
cuántica,
make it
no
more efficient,
necesitan y no
and
tienen
takes
por
an
qué
idea or inspiration from
utilizar
quantum
hardware cuántico para ejecutarse, ¿sí?
to
Entonces, lo que
utilize
vamos a hacer acá es
quantum
tomar
hardware
inspiración
to do this.
cuántica,
So we're going to take
pero
inspiration, quantum
es un poco extraño
inspiration,
el título, de los dispositivos analógicos,
but it's a very
¿sí? De
strange
ahí la
title,
televisión
from
y la tele.
analog devices.
Y vamos a contar un poco
So we're going to talk
cómo,
a
digamos,
bit about
surge esta idea.
how
Con más
this
o menos detalles, y hay
idea
algunas de estas
comes
cosas,
about.
matemáticamente hablando, que si bien la charla va a ser
And
amena y va a ser
mathematically speaking,
a lápiz, digamos, electrónico,
are
sin
going to make
escrito a mano,
this
espero que se entienda
interesting.
bien. La idea con esto
And I
es
hope you
poder
understand
contar un
with
poco
this idea
cómo ese
is being
juego de
able to
ideas,
tell a bit about
cómo se van
how the
conectando las
playing
ideas,
with ideas
esencialmente,
can be
investigar,
connected
para decir de una manera muy
essentially to
poética y muy
investigate
linda,
in a poetic way or a nice
significaría
way.
caminar, digamos,
It would
entre
signify
un mar de ideas,
walking
en un conjunto de ideas
through
que atraviesan
a
uno, con
sea
algunas
of
ideas en la mano. A
ideas
veces uno
or
va solo,
conjunction of
pero a veces uno
ideas
va
with
acompañado.
a few ideas in hand.
Y
And
ese es el trabajo
sometimes
de
those
investigación.
come alone
Esencialmente
or
es
might be
ir
accompanying. And this
haciendo que
is
estas
the
ideas que uno trae,
work of
que uno
investigating these
recoge,
with
que uno ve por
ideas
ahí,
that you might
interactúen
have or that
y
you
al
gather
final del día
and
tenga
interact
uno
with. And at the
otras
end of
cosas
the
nuevas,
day,
otras ideas para
that you
trabajar,
have
y después
new
esto parar
ideas to work on.
en
And then
artículos,
to be able
en
to
publicaciones, en
put
conferencias,
this into
en
articles or
desarrollo tecnológico,
publications
etcétera, ¿sí?
and
Bien, vamos a
technological
comenzar. Entonces,
advancement.
en principio, y
So
en
let's
primer
get
lugar,
started.
vamos a ver
In first
cosas
place,
que ya conocen ustedes de
we're going
el modelo de
to
puertas.
talk
No
about
vamos a
things
hacer,
that
como
you
les cuento,
might
ningún
already
relacionamiento
know
para que me entiendan un
of
dibujo muy sencillo.
the
Imagínense que
classical
tienen un
model
estado cuántico, un sistema
with a
cuántico.
very
Voy a
simple
poner un poquito más de cursor acá.
quantum
Ahí.
system.
Y el
Let me
estado
draw.
cuántico como tal lo tienen.
And
¿Qué
the
pasa?
quantum state,
Perfecto, ahí va. El estado cuántico como tal lo tienen escrito así. Este estado cuántico
you write it this way.
entra, ¿sí? A una especie de caja.
It
Este tipo de modelo
enters
ya ustedes lo conocen o
in
lo
this
habrán visto.
box, in this
Y
model that you might know or have seen.
se
And
pierde,
then
digamos,
it
final de
goes
cuentas, otro estado.
in the end to another state.
Que tengo una guía que me estoy haciendo para no extraviar y no perder el ritmo
I'm
de
doing this
la charla.
guy so I don't
Y
lose
esencialmente
you.
hay un operador que hace ese trabajo, ¿sí? Un
And
operador
essentially, this is
que
an
ustedes ya
operator
vieron
that does
propiedades
the
de este
job.
operador para que
And the
ustedes
properties
lo
of
puedan
this
implementar en una máquina
operator
cuántica como tal.
can be implemented on a
Un operador
quantum
como tal tiene
machine
que ser unitario,
as
¿sí?
such.
O sea, U es
An
unitario,
operator
¿sí?
is a
Vamos a
unit.
ponerlo en otro color. Bien, perfecto. Entonces, tenemos
We're
esto.
putting it here.
¿Y qué queremos
And we
decir
have this.
con
And
este
then
esquema? ¿Sí? Que
what do we mean
esencialmente
with this
la evolución,
scheme
digamos,
or schema?
temporal,
Essentially, the
bueno, una
temporal
cosa importante, ¿no? O
evolution.
sea, la evolución temporal, ahora vamos a comentar,
One
se
important
da en un
thing
circuito como tal porque
we're
hay
going to
un tiempo de
comment on,
procesamiento. O sea,
it's
el
a
estado
circuit
se
of
inicializa en la máquina
processing.
en el estado que
So the
fuere
state
y pasado
starts
un
in the
cierto
machine
tiempo se tiene el estado
and go
siguiente, por ejemplo,
after
a
a
la
certain
derecha
time.
de la imagen anterior.
This state
Pero
moves
digamos
to the
que
right
en
of the
general el
image.
operador U, como dije antes, es
And
unitario,
let's say
¿sí?
that in general, the operator, the
Y
unit operator,
en general se va a representar en computación
that's
cuántica
unit, is
como
represented
matrices,
in
¿sí? Son
quantum
matrices.
computing as
Pero
matrices.
en realidad lo que hay que tener en cuenta es que es
But
un
what we
operador
have
en
to keep in
principio
mind
cuántica para la teoría
is
cuántica.
that
Bueno,
it's an
eso después lo explico.
operator
Se trata de un operador
of
unitario
the
que
quantum
para el
physics
caso de la computación
as a
tiene la
Unitarian
forma de una matriz. Al
operator
final de cuentas tiene que ser digerible
that
por
has the
cualquier
matrix
sistema
form.
que compute cosas y no
So it's
puede haber
digestible by any
cantidades
type of
infinitas dando vueltas por ahí.
computational
Es un
system
operador,
of infinite
si quiero
quantities
ampliar la palabra, no es lo que digiere bien una
in
computadora
the
cuántica ni
loose
clásica
sense of the
tampoco.
word is
Bien,
not
entonces si
defined by the
extrapolamos
quantum
esta
or the
idea, digamos,
classical
como
models.
digo, ¿no? Pasamos
So if
del
we take
esquema de
this
puertas
idea,
anterior en el cual hay
we
matrices,
take from
ahora
the
operadores,
gate scheme
podemos ver que en el
to
esquema
now
anterior,
operators.
bueno, evidentemente vuelvo a
We can
reescribir,
see that
pero
with
esto
the
ya es por
previous
sintaxis, para
scheme
empezar un
that we
poco
were looking at.
con la nomenclatura del tema. Voy a tener esto.
We
O
write
sea,
this out,
el circuito responde a una
and you can have
operación
this.
algebraica
The
ejecutada un
circuit
operador. Es un operador que,
resolves
como lo
a
pueden ver ahí,
algebraic
lineal,
operation
¿sí?
that's
Por cómo está
linear
escrito, ya habrán visto, y de hecho lo
by how it's
comprobé, que
written,
habían visto la notación de bracket de Dirac,
and
así
I
que
was
esto
able to
debe
prove
sonar
this.
conocido.
So this should all
Y
be familiar to you.
el hecho de que el operador sea lineal, bueno, trae consigo un
And the
montón
fact that this
de
is a
ventajas
linear
y de propiedades.
operator has
Es uno de los
certain
postulados de
advantages,
la
as
teoría
I've
cuántica, de la
mentioned.
física cuántica,
It's
el
one
hecho
of
de que
the
las transformaciones
postulations
sean
that
dadas,
these
los
transformations,
cambios en los estados del sistema cuántico sean dados por un
the
operador
changes
unitario
in the
y un
states
operador lineal.
of the Unitarian
Eso
operator
automáticamente te deja
to a different state.
la superposición y
This
demás,
automatically is a
generalmente
gift of a
superponer, o sea,
superposition.
combinar linealmente estados corresponde a otro
of
estado, y
combining
los
these
operadores
states,
aplican sin problema a cada componente
and
de
the
esa combinación.
operators
Entonces,
are
al final de cuentas,
applicable
todo queda
with
entre K.
certain
Bien,
combinations.
bien. El
So,
esquema que comenté
what
antes,
else?
¿sí?
The scheme that I
Del
was commenting on
estado
before,
original que dijimos, que es phi,
from the original state
¿sí?
that we mentioned,
y habíamos puesto acá en el medio de la caja esta, ¿no? El operador en cuestión
and then we
U,
put the box in the middle.
como dijimos, pasa un cierto tiempo, ¿sí?
As we said,
Acá
after a
pasa un
certain amount of
cierto
time,
cierto tiempo t, y
time
lo que uno
as
hace en
t,
realidad es, en un circuito, cuando uno nace con un circuito,
what
etiqueta
one does
temporalmente
then in
digamos,
tag
básicamente
of
es
a
una etiqueta,
circuit,
es un número discreto, ¿sí? Un salto de tiempo.
it's a tag or it's a
Pero
discrete
quiero
number
abstraer
of
la idea.
time.
Si ahora abstraemos la idea y
I want to
pensamos en
abstract
tiempos
the idea.
continuos, ¿sí?
We're going to
Es
be
decir,
thinking
t
of
ahora puede ser un
continuum
número
times.
cualquiera, un número real.
So t could then be
Lo que
any
podemos
type of
escribir
real
en
number
general es lo siguiente.
or time.
Fíjense, estoy pensando
And
cómo
what we can write in
lo
general
escribo
is the
sin dañar
following.
nada. A ver,
This is how
ahí
I
está.
would
Vamos a
write it
pensar
out.
en un sí
So we
o la
think
letra que le
about
quieran poner, porque esta letra
a
es
sig or any
escribía
type of
pi
letter.
también, pero es una variante de la anterior. Fíjate, lo
This is a
podemos pensar como
variable
una curva
that we
ahora,
mentioned before.
¿sí? Que
And
va
then
de
we're
los
going to
reales
make
a
a
la última
curve
subconjunto de los reales
that goes
y
from
cae en el
the
espacio de G en el
real
que toca.
conjunctions
¿Está
and
bien?
then falls
Completo. Y
into,
en particular, cuando
and
va
then
de 0 a su
particularly
parámetro tiempo,
when
tengo el
the
estado
value is
inicial,
0 of
y
time,
cuando
then it's the initial
pasa un
stage,
tiempo t, de ese tiempo de
and
cómputo, digamos
after a
así,
certain amount of
tengo el
time
estado o el estado que
or
habíamos dicho
computing
antes.
time,
¿Sí?
this
Pero lo estoy pensando como una
state
curva ahora.
changes, as I mentioned before.
Bien. Estoy
So right now
asociando la idea de
I'm
evolución
putting this as a H
temporal
curve.
porque quiero introducir justamente algo que ya
So
todos
this is a
conocen,
temporal
que es
situation
son líneas nada
that
más.
you might be familiar with.
La ecuación, digamos, que rige a los sistemas
The
cuánticos, por lo menos
equation
en su
that you
versión
see
no
here
relativa.
of the quantum systems in
Bien, y
its
a la
version
siguiente,
that's
es la
non-relative.
conocida por todos,
So
que
then
podemos
on, the one
escribirla
that's
así.
known
Ahora
by
que tengo
everybody,
un vector
we're going to write it
que
this way.
evoluciona, puedo
So we have a
repetir
vector that
la ecuación
evolves,
anterior así, y estoy hablando
and
de,
the previous
ahora puedo hablar
expression.
de el estado al tiempo t y
So
el
now we
estado al
can
tiempo
talk
cero
about the state
del sistema
in
cuántico del mismo sistema.
time t
Y no de
and
estados así
the
cualquiera,
state
sino
in time
de
0.
algo que sigue el estado del
So we're talking
sistema
about
en todo
something that
tiempo. Ahora el tiempo es,
follows the state
como
of the
dijimos, es una
system,
variable continua.
and then
¿Sí?
time is a variable.
Entonces, esto simplemente para llegar a esto. Y ahora,
So
si,
now,
como dije antes, si paso a considerar
if we go
al tiempo como
from
variable real,
considering
tengo lo
time as
siguiente,
something real,
¿sí? Que lo pueden ver también con
I have the
circuitos.
following,
Tengo lo siguiente, que es
which we can also do in
que
circuits,
U de t más
that
s,
u
o sea, la suma de dos tiempos,
of theme
es igual
t
a
plus
U
s
de t, como
equals
son matrices en este
u
caso, o, de hecho,
of
en
t,
sentido más amplio
these
son
are
operadores, pero
matrices
si lo piensan como matrices funciona
or
igual,
operators,
producto
but we
con
start
U
as
de S.
matrices, and
Y
the
hay una especie de
product
regla de
of
composición acá.
u
Hay varias
of
formas de cuantificar
s,
esta regla de
and this
composición.
is
Estoy
the
trabajando con
composition of this.
sistemas separados, digo, para algún físico que por esto lo vea
I'm
o
working with
matemático,
separate
que pueda
systems,
conocer más, estoy
as you
tratando,
can see
U
mathematically,
como tal, se suele llamar en la
that
literatura como el
u
operador
as
evolución,
such
¿no? Y lo que estoy ahí tratando es
is the
la
evolutionary operator.
invarianza,
And what I'm trying to
¿sí?
do
Temporal.
is the
Es una manera
variance of the temporal way,
digamos,
a
de
way
poder
of
justificar esto. O sea, lo que estoy diciendo es esto. Vamos a hacerlo de otra
justifying,
que queda más,
let's do it
entendible, más
in a
corta para
different
todos.
way
Es la siguiente.
that
Fíjense,
might be more
si yo
understandable.
trabajo con un circuito
So let's see,
que
if we work on a
implementa
circuit
la evolución
that
T
implements
más S,
the
o sea,
evolution
la caja que hace
of
esa
t
magia,
plus
digamos, de pasar el
s
vector, el estado
of
inicial
u
al
vector
tiempo cero a un
from the
tiempo T más S,
initial state to
este
a
operador se
time
puede
of t plus s, this
descomponer
operator
como la
can
aplicación
be
sucesiva de U de T,
decomposed
o
by
mejor de verdad de
u
U de
by
S,
t.
aunque
Sorry, let's start with u and s,
comentar que son
and
rotativos,
then
pero no importa, bueno, U de T,
u
ahí está.
by t.
Y esta estructura o esta regla
And
de
then
composición,
this
junto con
structure
otra
of
propiedad
composition
anterior que la puedo poner acá
has
y
other
que me parece que
properties,
se podría
like
incluso deducir
previously,
de esto que está acá arriba, es que
that we can deduct from
junto esto,
the top
junto
one.
con que la U de
So
0 es
we
igual al
add
operador
this
identidad
of
o la
u
matriz
of
identidad de
0
matrices,
equals
cierra una
If
estructura de
this was
grupo
matrices, so it closes a structure of a
grupos de
grouping
usabilidad, un montón de propiedades.
automatically
A lo que voy con esto
with
es, el
several
operador
different
de
properties.
evolución, que es U en este caso,
So
que
the
hace la
evolutionary
evolución temporal del
operator,
sistema,
the one that does the temporal
tiene esta estructura
evolution,
de grupo. Entonces, de acá
does this
surge
type of
también, de
grouping
manera muy
structure.
natural, lo siguiente.
And this comes about
Se
very
puede hacer de varias
naturally
formas
in
esto,
the
esta es
following
una
way.
manera de hacerlo.
You could do
Uno
it in
puede,
several
o bien,
different ways.
definir U
You
más
can
0, o sea, la derivada del
define
sustituidor respecto
this
del parámetro
as
en
u
0 lo define como
prime of
i
0
veces un
equals
operador, ya lo estoy poniendo demasiado obvio,
minus i
h, que va a
as
ser
the
el que veremos
operator
más adelante,
of h,
o puede
which is the
hacer
vector
algo similar
later on,
a esto, que es
or you could do
que
something
de lo que
similar
puse
of
antes, esta
this.
estructura del grupo, se
What I
puede
did
deducir una
before
ecuación
of the
diferencial.
structure of the grouping,
¿Está bien?
you can
O, dicho de otra
deduct
manera,
a
se puede probar que
differential
el operador que
way,
satisface esa
or you
estructura
could
de
prove
grupo,
that the
como son
operator
operadores
that
unitarios, se
satisfies
pueden escribir
this
siempre
group
como U de
can
t,
be
un
written
elemento de ese grupo, va a
as
tener
u
siempre la
of
estructura de
t
e a la menos i
as an
del
element of the
parámetro
group,
t,
and then
por
e
un operador
minus
que tiene
I
que ser
of t
crítico.
by
¿Sí?
an operator,
Pongo directamente h
which
porque
has to
ya,
be hypothetical, like
digamos,
h.
para
I
que sea
put
más natural para
h
verlo, pero pueden poner un operador cualquiera y
because,
después reconocer que es el
but you can use any
hamiltoniano
operator
cuando llegue a
to
lo que
recognize
a
that
lo que
it's the
justo ahora a
Hamiltonian
continuación. Es lo siguiente, fíjense,
that we're going to utilize
si
next.
parto
So
de la expresión
let's
anterior,
see this.
la que relacionaba dos
If I
tiempos,
start from the
tiempo igual a
previous
t,
expression
tiempo igual
of
a 0, y
t
con un operador de evolución
equal
como tal,
to u by t
podría
by
derivar
y0,
respecto del tiempo
I could
a este
derivate
vector
this
la
time
curva, al final de
vector,
cuentas, está parametrizado con el parámetro t,
that's
lo
a
podría
curve,
derivar respecto del tiempo, lo voy a escribir
with
de manera
t
compacta así,
parameter.
derivada respecto del tiempo.
We can
Acá
compact
lo voy a
it
escribir
like
también
this.
así, ¿sí?
And here I'm going to also write this
Aprovechar
over here,
justamente que la derivada que acabo de
and
deducir
then take
antes, o acabo
advantage
de,
that I just
digamos,
deducted this
definir, como
derivation
lo quieran llamar. No tengo mucho problema
to
acá
define
con
it.
el rigor formal, quiero llegar al tema como tal.
I don't want to be
La
very
derivada de
rigorous.
esto
I just want
es
you to
menos
understand
i,
to
el
derivate
operador,
this term and write it as I of operator u, and then t,
perdón, al revés, estoy escribiendo al revés.
h.
Se me ha olvidado.
Sorry, let me start this over.
Es el operador
I
u
minus
de t.
ih, and then u operator by t, and
Y
then
esto que está
y
acá es
by
el
0.
estado
And then
activo del tiempo,
this right here
y esto que está acá
is
es
times t,
la
and this is
ecuación de
I
Schrödinger.
minus
¿Sí?
ih.
Esto es algo,
This
una
is
manera
the
de
new
obtenerlo a
equation.
partir de
So it's
una regla de
another way of
composición, de
obtaining
cómo evoluciona
this.
en el tiempo.
It's
Tiene
a
una imagen
composition
pictórica,
rule,
un circuito, ¿está bien? Que haría
but it
eso.
has a pictographic image of
¿A qué voy
this.
con esto? ¿Sí? ¿A dónde quiero llegar?
What am I getting at
Voy a ir
with
a lo siguiente. A
this?
ver, fíjense, imagínense que ahora tomo una
Is the
base
following.
concreta,
Imagine that then I take a
finita,
base,
digamos,
a
tomo una
concrete
base
base,
concreta,
a concrete base
n
like
pertenece a un
this,
conjunto de índices de n elementos, n
to
mayúscula
have a
elementos, o sea,
conjunction of
n puede ir, n
indexes.
minúscula va desde 1 hasta n mayúscula, es una base ortonormal, lo que suele
N
elegirse
is our
en
base
cuántica, y puedo proyectar la
in
ecuación de
the
Schrödinger
quantum
en esta
way
base.
of writing,
Lo voy a escribir más rápido directamente, pero acá podría tener ya
and then I'm going
algo
to
como lo
write it
siguiente.
quicker in the following way.
Phi de n, ¿sí? Lo defino entonces
Phi
como
of
el
n,
bracket
I define
de
it as
proyectar, digamos,
less than n
la curva
of
esta abstracta del episodio
phi
de Hilbert en
by
esta base
t, or
concreta,
time,
y tendría
and this is a
lo que se llama
curve.
la coordenada de un vector, que puedo arreglar en un vector,
So we
el
have the
vector phi
coordinates of
mayúscula,
a vector,
o sea, phi o phi
a
n línea, si
phi
quieren, que
vector
vector columna, por ejemplo, que sea phi 1
equals
hasta
vector
i
column
sub n
of
mayúscula,
1
y esto
to n,
tendría, por
and
ejemplo,
this
una
then
ecuación
would
diferencial
have
también
a
matricial.
differential
Ahora,
equation
antes estaba
or
hablando en términos
matrixed.
de la matriz, pensándolo, pero podría ser un operador
Before I
exactamente
was
igual.
talking
Y ahora
of
ya esto tiene
matrix
la forma de
terms,
una matriz
but
como tal,
now this now
donde
has the form of a
el
matrix,
hamiltoniano esta matriz
where
hamiltoniana,
the
se
Hamiltonian
compone de los elementos de
here
matriz
is
formados
composed
por
of the elements of the matrix
el bracket
conformed by n and h in
m,
bracket
¿sí?
and m
En la base que estoy eligiendo, ¿no? La base n esta que
in
estoy usando.
the base that we're using, which is this one.
Entonces, este es el operador y esta es la matriz. ¿Sí?
So this is the operator and the
Bien,
matrix.
¿a qué voy con esto? Y acá entra
So,
un
what
poquito
am I
la
getting at
parte
with
de los
this?
analog devices y demás que veníamos comentando. Voy a ir un poco más rápido.
I'm utilizing the analog
Es lo siguiente.
devices
Em,
and is the following.
Existe, digamos, una manera, si quieren quedar con la
There
ecuación
exists a
anterior,
way
la ecuación
to
anterior, a final de cuentas era la derivada
deal with the
igual
equation
que
that we previously saw,
h
which is
y
time equals minus
phi.
I, h
Piensen
by
en phi
y
como
and t,
la parte real más la parte imaginaria.
p
¿Ok?
as the
Y
real way and
podría
imaginary.
escribir, digamos, una
You
ecuación
could
diferencial,
also
o sea,
write it
podría
in a
lo que se llama
differential equation,
separar la parte real imaginaria.
which is
Técnicamente en matemáticas se llama
separate the imaginary
complexificar
from the
esto, que es
real
pasar esencialmente
to
de las
make it not
componentes,
as
digamos, del
complex
vector
of the
complejo a sus
components.
componentes, que son también vectores, pero reales ambos
I
dos, la parte real y
divide
la
the
parte
different
imaginaria
components of
de ese
it,
vector
the
complejo.
real
¿Sí?
and the
Este es
imaginary.
complejo, este es real y este es real, y si tienen n componentes,
So this is
todos son
complex,
vectores,
real,
pero
and real,
un
and these are
complejo
all
lo tengo
vectors,
con dos reales.
but it's a
Bueno,
complex
si hicieran
with two
la
real.
descomplexificación de esto, les quedaría un sistema de ecuaciones
If we
para la parte real y la parte
make
imaginaria
it
que está
more simple,
mezclado,
of the real and
en física se
imaginary
dice que, bueno,
parts,
que interactúa una parte con
these are
otra, que no
mixed
podés
in physics.
desacoplarlas.
We say
Pero si te
you
vas a
can't
orden 2, o
uncouple them,
sea, si podrías
but
encontrar una
if you
ecuación
go to
diferencial de
the second
segundo
order,
orden, o sea, de una derivada
you
segunda en el
could
tiempo,
do a
puede que esa
differential
ecuación
of second order.
quede desacoplada. Y la ecuación es la
This
siguiente, que es
equation
la derivada
then can
segunda
be uncoupled.
más la derivada
So you
primera
do
de la
a second
matriz
derivation of
más
the
la derivada,
second by the
perdón,
first
sí,
and the
o sea,
matrix,
se puede
and
derivar
then
por
plus
otra
the
matriz.
b
Esto para
by another matrix,
eh,
and then this
con i igual 1 o 2, o sea, para
with
simbolizar
I
la parte imaginaria y la parte
equals
real
1
del
or
vector.
2
O sea, ¿qué
of
quiere
the
decir esto?
imaginary.
Bueno, son todas
What can
funciones de
I say
tiempo,
with this? We're
esto es
doing
la raíz,
t
¿sí?
as the
Ahora, a lo que voy
function,
es a esto.
and then what am I
La
getting
parte
at with
real y la parte
this?
imaginaria satisfacen una ecuación
The
de
real and
segundo orden
imaginary
en la cual está
parts
cada una
of
desacoplada. De
a
hecho, es la misma
second
ecuación
order
para la parte real y
equation.
parte imaginaria. Esto
This is
pasa
the same
en todos los
equation,
sistemas cuánticos,
but this
descrito por
happens
la
in all the
ecuación de
quantum
Schrödinger que vimos
systems,
al principio, en una base
written by
finita,
the
etcétera,
equation of
como la
Schrödinger,
enumeramos antes. ¿Sí?
as
¿Qué tiene de
we
interesante
enumerated.
esto? ¿Sí? Lo siguiente,
What's interesting about
que
this?
ecuaciones de
The
segundo
following.
grado, o sea, ecuaciones
Equations of
de orden
second
2, mejor
degree
dicho, diferenciales,
or
aparecen en
second order,
muchísimas situaciones en la física
they
clásica.
appear in a
Sistemas
lot
que
of different
oscilan, o sea,
situations
sistemas
of
que,
classical physics,
esencialmente en osciladores, si quieren,
systems
osciladores que pueden estar amortiguados
that
por alguna
are
derivada
between
primera. Para quien conozca algo
oscillators
más de física, esto les puede
of
sonar.
first
Entonces, ¿qué pasa?
derivation and can sound
A
familiar.
raíz
So,
de estas ideas, o de esta
in root of these ideas
decomplexificación de la ecuación diferencial de Schrödinger en dos
of
ecuaciones reales,
decomplexifying them
se observa
from imaginary to
cierta
real,
conexión con,
we
con
can
los sistemas
observe
físicos
certain
de
connection
la
with
física
the classical
de
systems
oscilaciones. Pero en vez de
of
irnos
physics
a la
and
física de
oscillations.
osciladores construidos con masas y con
But
resortes y
before
con
going to the physics of
amortiguadores, algo
oscillations,
mecánico,
of
em,
amortization of
nos vamos
something
a ir a
mechanic,
otro tipo
we're
de
going
oscilaciones que son las
to
oscilaciones eléctricas.
other
De
type
ahí
of
el tema de la
oscillations
charla
that are
de
the
positivos
electric
analógicos. Vamos a
oscillations
ir a redes eléctricas,
of
redes de circuitos
analog
con
positives,
resistencias,
uh,
inductores,
networks and
capacitores,
circuits
etc.
and
¿Sí?
resistances and motors and
Y lo que se puede ver,
capacitors, etc.
esto con un poquito de
And what
trabajo,
we can see
en un
with
paper
a
en
little
el
bit
que había
of
estado
work
trabajando, es
in
un
a
paper que
paper
lo
that
pueden
I've
ver en
been working
archive
on
en este número, a ver si
that
puedo
you can see in the
agarrarlo,
archive with this number, that
10402,
which I'm writing right now,
esto lo ven en archive,
04 and 02,
mal, entiendo.
RxIV.
Lo tienen ahí, ese
This is
paper, y
badly
ahí,
written from what I
está
understand,
contado,
but
digamos,
you can look in this
cómo
paper
tener
and you can see how
esto que voy
you
a
can
comentarles
obtain
ahora, que lo voy a
this,
intentar resumir.
this that I'm
Que es
going
lo
to
siguiente. Fíjense, vamos a dejar esto por
tell
acá.
you right now, which is the following. Putting this over here.
Si se acuerdan,
And
las dos,
if you
tanto
remember,
la parte real como la parte imaginaria, satisfacen la misma ecuación diferencial. Perfecto.
the
Bien.
real part
Entonces,
and the imaginary,
se puede
you can see
probar
the difference
que
here.
una
So we can
topología
prove that
de un circuito, como la que voy a mostrarles
topology of
ahora,
a circuit,
muy
like
simple de
what
hecho,
I'm going to show you
uno
right
lo ve
now,
y va a decir,
is
¿qué
very
es nada más?
simple, actually.
Tengo un oscilador ahí, acuérdense
I
que
have
voy a
an
hablar de
oscillator.
oscilaciones. Esto se
We
conecta
talked about oscillations.
a
This
un par de
connects
puertas.
to
Estos son
a
nodos, por ahí
few
voy a resaltar, son
gates
nodos, no se
or
asusten, son nada
nodes.
más que eso. Y
These are just nodes, don't get scared.
traerlo esto,
And in the
una
middle,
red
it connects
N,
with the big
y
network
otra red
of N,
que es una red
and this network of
dipolo
N over
reactivo,
here,
un oscilador sencillo, un LC,
a
N sub N,
simple
para que
oscillator
hacer referencia
of
a
N
los,
by N
a los capacitores inductores de esa subred. Y
to
así
the
tuviera
inductors or
varias otras
capacitors of
conectadas,
this
y
network.
tendría varias
And
otras
then there's
conectadas.
many other that are
Si yo
connected.
elijo esta
And if I choose
diferencia de
to
potencial entre estos nodos, entre estos dos nodos,
use
B sub
this
n,
difference of
se puede
potentiators,
probar que
you can
si la
prove
red
that
eléctrica esta, tiene que
if
elegir
the
una red
electrical
eléctrica
network of
concreta,
this
y hay
one,
formas de hacerlo, hay formas de sintetizar
which is
una red
concrete, and
para que
there's a
haga,
way of
para que cumpla una determinada
synthesizing or
ecuación.
doing it
Pero si esta
so
red
that it
eléctrica
meets a
adentro de
determined
esta red tengo que
equation
resenar con ciertos
inside of this network.
elementos, pueden ser capacitores,
I have to fill
inductores,
with certain
quiero
elements like
definición de los elementos,
capacitors,
después hay algunas mejores que se pueden
inductors
googlear, ¿sí?
that you can Google.
Y para decirlo rápido, esas matrices A y
And
B
to say this
están
quickly,
metidas acá
these
y acá
matrices
adentro,
can
casi,
also
porque esta B
show
estrella
here and
es
here
en
inside.
realidad la B anterior,
This is
¿sí?
actually
Menos
the previous
una
B
matriz diagonal
minus
que tiene
a
las
diagonal matrix
frecuencias
that has the frequencies,
propias
their
de
own
cada
frequencies
oscilador,
of each oscillator,
de cada circuito oscilante como este, y de cada oscilador.
of each circuit that's an oscillator
Entonces,
shown here.
¿a qué voy con esto? Si
So,
hacen todo esto, siguiendo
what
el
am I
procedimiento
getting at with
este
this? If
trabajo,
you do all of
se puede
this,
probar que la evolución
you
temporal
can
de estas
prove
diferencias de tensión, de
that the
estas
temporal
potenciales,
evolution of this
sigue la ecuación que comentamos antes.
con
Entonces, si uno va
continues
para
the
atrás de la película,
equation that
lo
we
que
were
está
talking
haciendo es
about
construir un
before.
circuito eléctrico
So what
que
it's doing
pueda
is to construct a
simular,
circuit
no toda
that
la cuántica,
can
evidentemente, no es eso lo que
simulate
pretende,
all
simular
of the
ciertos aspectos.
quantics,
O sea, por ejemplo, la evolución
simulate
temporal.
certain aspects, for
Bueno,
example, the
no pretende ser mucho más.
temporal
Hay más cosas que se pueden hacer, pero para contarlo así, de
matrix.
manera resumida,
There's many more things that can be
tendríamos
done,
esto.
but
Con
in
cierto
a
zoom.
short way,
Y
this is what we would
lo
obtain.
siguiente ocurre.
And
Em,
then
Bueno,
the
en
following.
particular, si quieren, ¿cómo es
In
n? O sea,
particular,
n depende de
if you
los
want,
elementos de matriz que dije antes,
how do
de
we
las
find
matrices
n?
anteriores.
It
Y si
depends
queremos
on the
mantener un diccionario
elements.
más fino, para un caso
And you can have
bastante
a
general,
finer
A y
dictionary
B, las matrices
for
A
a
y B,
general case,
están
like A
relacionadas
and
con
B.
la parte
Matrices A and
imaginaria del
B
Hamiltoniano
are
en la
related
matriz,
to
y
the
la B
imaginary
está,
Hamiltonian,
es igual, de hecho, a la
and the B
parte real, la
is
matriz,
the
digamos,
same
la parte
as
real
the
de la
real part
matriz
of the
hamiltoniana al
matrix,
cuadrado más la parte
of the
imaginal al
Hamiltonian
cuadrado.
matrix,
¿Sí? Tienen esta
plus the
relación. O sea,
imaginary part.
n se
So it has
forma
this
con
relationship.
estos elementos,
N
a
is
esta matriz
formed
B hay que extraerle la
of
parte
these
esa de
elements,
la diagonal que comenté antes. Bueno,
B
esto no tengo que ver en el
matrix
trabajo.
that
A lo que
we
voy
have
es
to
que
extract.
hay un circuito eléctrico que hace
And
esto,
what I'm
que
getting at is
permitiría
that there's a circuit
tener
that
condensar la evolución
allows
temporal de un sistema cuántico como tal.
and
¿Por qué quiero hacer
condenses
esto?
a
Quiero volver,
quantum system like
que es una
this.
especie de
Why do
vuelta
I
hacia
want
lo
to do this?
analógico. Es que
Because it's
soy
a
una
way
persona renegada
to
y por eso hablo
go
de esta
around in
tradición
a logical way.
de los 70.
Um,
No, es
as
que
I'm
hay
in this little
una
TV from the
vuelta, y es la que voy a
70s,
comentar ahora. Hay una posibilidad de volver
there's a way to go
a
around it
algo interesante
to
a
return
posteriori usando
to
estas ideas.
something
¿Qué es lo siguiente?
interesting
Es
of synthesizing these
justamente,
ideas,
si uno
which are
quisiera tratar, por ejemplo, con hamiltonianos,
if one
de los
wanted
hamiltonianos
to
que condensan al
deal
final
with
la mayoría de las
Hamiltonians
operaciones en cuántica. Voy a
that
ponerlas todas juntas
condense
para que se
most of
entienda,
the
pero puede ser cualquiera de esas
quantum
atendiendo a un coeficiente o
operations,
no. Yo tengo
you
coeficientes
can use any of them using
por la
this
identidad, otro
coefficient
coeficiente por sigma 1, que son las matrices
with
de Fabry.
another coefficient
Esto por sigma
and
2,
sigma 1
esto por
and
sigma 3. Al
sigma
final de
2
cuentas estoy escribiendo
and
ahí
sigma
la
3.
matriz hermítica más
In
general
the
que puedo
end, what I'm
escribir
doing is
en
writing the general
el operador
matrix
más general que puedo escribir para, digamos,
of
para
the
tratar
operator,
sistemas
that's the most
cuánticos
general one, to do quantum
de un qubit. O
systems
sea, las puertas de un qubit. Las puertas
of one
estas,
qubit
¿sí? Las
or
escribo acá, nada más,
gates
no
of a
estoy
qubit.
diciéndome todas.
This is what I'm writing right
¿A qué
here.
voy con esto? Que hay un circuito,
What am I
por
getting
ejemplo,
at?
como caso particular,
Is
que
there's a
corresponde a
circuit,
esto,
for
a este
example,
hamiltoniano. Y si
that
hago
corresponds to
cero alguna de estas
this
cantidades,
Hamiltonian.
tendré el
And
circuito
if I do
equivalente que
0 on
corresponde a la
any of
puerta
these
de Fabry,
quantities, I will have an
sigma X,
equivalent
sigma Y,
circuit
sigma
that
Z, por ejemplo.
is
Nadie
equivalent
entiende, la
to
verdad, que
the
desde el punto de vista de los
gate of
circuitos es
this,
colocar un cable. Así que muchos
of
circuitos
the
se
point
entienden
of
por
view
eso.
of the
Pero van a
circuit
entender
with
lo
the
que voy.
cable.
¿Sí? Em,
But You following where I'm
¿Qué
going?
otra cosa? ¿Para qué otra cosa podría servir? Este es un ejemplo.
Another thing.
Este es un ejemplo
What else can we use it for?
de,
This is just an
de
example
uso
of use
del circuito, ¿no? De las redes eléctricas estas,
of a circuit,
que son como
of the electric
equivalentes
networks
a,
of N
los,
that
vamos a
are
poner así,
equivalent to
sistemas
of
cuánticos, ¿está
systems,
bien? Con las salvedades que hicimos antes.
quantum
Sistemas
systems,
cuánticos en el contexto que lo conté
like what
antes,
we
con la
did
ecuación de
before,
Schrödinger, espacio de estados finitos, toda la cuestión.
with the conditions that we talked about.
Bien,
And
¿y
very
para qué
well.
otra cosa podrían también
And
servir
for what other
estas
things
ideas?
can we also
Bueno,
utilize them?
en otro trabajo le voy a poner
Another
mejor,
job we can do,
vamos a ponerlo
let's put this to the side.
bien. Vamos a, no, mejor una página más.
Very well.
En otro trabajo
Let's just, yeah,
también
take it away.
les paso
So
las citas
another job we
de
can
web para que
do,
lo puedan ver, para que todos puedan acceder.
I'll put the archive
2304
quotation 2304.06487. Yes.
Justamente se usó una colección que hay entre estas
And
citas
with
que estoy mostrando
this,
con otra
we've
cosa. Y hay
utilized a
otro
collection
salto que quiero comentarles que uno puede hacer.
that
Un
has
pequeño
another
salto.
jump that I would like to take you
Fíjense,
through.
este paper
These are small
cuenta
jumps.
sobre
This is a paper that
lo
tells us
siguiente. Lo voy a poner acá como un
about
punto, porque el
the
paper habla sobre eso,
following.
pero esto
Point
de lo
number
que habla el
1.
paper lo usé para otras
The
cosas
paper
más
talks
y
about this.
mezclando todas las ideas que
I
comentamos antes,
utilized it for
llegamos a
other
una
things,
conclusión para cerrar la
as I
clase,
was
cerrar el
mentioning
tema.
before,
En ese paper
and
se mostró que las
we're going to close out this
redes
session today.
neuronales recurrentes, ¿sí? Otra cosa,
So
¿no?
the
En principio.
recurring neuronal
Ciertas redes neuronales
networks,
recurrentes, de hecho se puede hacer con todas, pero bueno, en
neural
particular ahí tratamos
networks.
unas particulares, se pueden
In
corresponder
particular,
a redes
we
eléctricas,
dealt
o sea,
with this one
electrical
that
networks,
corresponds
de
to
lo que vimos recién,
electrical
con la
networks
topología que vimos antes, bastante
that we just saw,
¿sí?
with the topology that we just saw.
Y después se
And
sabe
after that,
que, por ejemplo, en una red
number
neuronal
2, we know,
recurrente se puede
for example,
implementar
that in a
descenso de
recurring
gradiente.
neural
¿Sí? Vamos a ponerlo
network,
en inglés, para que me
you
acuerdo.
can find
Eh,
the gradient
bueno, ahí está. A lo que voy.
derivation. So what
Si
am I getting
colectamos
at with this?
justamente estas
If we
ideas, pueden surgir
collect
varios trabajos, de hecho, se están
these
desarrollando
ideas,
muchas de estas cosas ahora. La
we're
tercera
discovering all of these things
y otras
now,
más, pero voy a contar
the
solamente
third,
una, que
and a
simplemente
few others,
uniendo
but mainly this,
estas cosas en las que
is
vine charlando.
uniting
Podríamos pensar entonces
these
en,
things that I've been
perdón, me
talking
faltó la tercera.
about. So we start with,
Existen
the third.
circuitos, vamos a ponerlo,
There exists circuits,
cuánticos, ¿sí?
quantum circuits,
Bueno, que está en inglés. Espero que se traduzca, pero bueno. Quantum circuit, ¿sí?
I hope we
Circuitos
can
cuánticos
translate
que
this, but yes,
pueden
anyway.
implementar
Quantum circuits
justamente
that can be implemented
que implementan, voy a poner acá, que
exactly,
implementan, por ejemplo, ecuaciones
for example,
diferenciales
equations
de
that
primer orden. O dicho de otra manera,
are
que pueden
differential
implementar
equations
el descenso del
or
gradiente,
can
¿sí?
implement
Mejor dicho, se
organic
pueden usar para eso, no es que están
descents.
pensadas para eso. El paper originalmente
That
no
can be
trata
used
sobre
for
eso,
this.
pero se pueden adaptar para
The
eso.
original paper is not
Entonces,
about this, but can be adapted for
lo que
this.
surge es que primero tenés como
So
varias líneas acá para seguir
what
trabajando.
comes out of this
Podrías
is
irte por la
several
línea de
lines to work
trabajar
on.
con circuitos cuánticos que permitan entrenar
You
modelos
can work with
de
quantum
machine learning, o
circuits
sea, un circuito
that
que
can
se
train new
inicialice
models
con un valor, el estado,
and
digamos,
can
del
be
circuito
initiated with a
codifique
value or a
bueno,
state that the
un
circuit
teorema de optimización
then
que está
codifies
detrás del descenso del
and
gradiente y
optimizes
al
the
final,
program.
a la salida del circuito tengas
And at the
tu modelo
end
entrenado. Lo estoy diciendo
of the
muy rápido y
circuit,
muy mal
you have
para
this
que vaya
new
más rápido.
model.
Pero
I'm gonna
justamente
move on to go
otra de las
quicker,
cosas
but
que
with
uno puede
this,
seguir
another
trabajando es
thing
en
that
un
you
un
see
circuito
is
cuántico,
that you
por
can work
ejemplo,
on
que
a quantum circuit,
implementa
for
el descenso del gradiente,
example,
esa es una que le dije recién, y la otra
that
es
implements
trabajar con
this,
circuitos clásicos
and then
que hacen el
work with
trabajo de
classical
entrenamiento
circuits
de una manera
that do
más
the work
eficiente,
of
porque
training
computan de una
these
manera
in a more
analógica,
efficient way
más
and
rápida en
compute them
principio
in a
que lo que hace una
analog way
máquina
that's
como la
quicker
que estamos
in
usando
principle
ahora para ver
than what a machine
esta
would
sesión.
do
¿Sí? Bien,
that
entonces
we would be
como
using for this
conclusión,
session.
y acá con esto termino,
So in conclusion, I'm almost done.
La voy a hacer más bien hablada, más que conclusiones, porque lo que me interesa
I'm
a
going
mí
to talk
es
this through.
comentar para no perder
What
tiempo
I'm
media
interested
hora y
in,
demás. Y con esto cerramos. ¿Sí? Primero que
and
vimos
anyway, we'll close out with
desde el
this.
concepto de
We saw
circuito cuántico se
the
puede
concept of
extrapolar
quantum
esa idea, se puede
circuits,
abstraer esa idea
that we can
hacia
extrapolate
algo
or
que
extract this
en realidad
idea
en la física se
to
conoce antes que los circuitos
something
cuánticos, que es la evolución
that
temporal de los
in
sistemas.
reality
Lo que pasa es que lo
physics
quise traer desde los
knows
circuitos, por si
temporally
justamente alguno de
from
ustedes
quantum physics.
su
And
primera
I want to bring the
entrada hacia la
circuits
cuántica fue con computación
as a
cuántica, entonces están acostumbrados a
new way of
pensar en términos por ahí
entering
de
the quantum
circuitos, quizá,
computing
y entonces
and to think
es una
of
manera cómoda de
terms of
traer a todos
circuits
hacia este mismo lugar,
and a
que es
comfortable
la
way to
evolución
bring all
temporal
of
de los sistemas
these
cuánticos.
in.
Esa
And
evolución
the
temporal
temporal
se puede
evolution of the
escribir, se
quantum
puede escribir
inspiration.
con,
This
para
can
que
be written
así
out
se ve más fácil. Esa evolución temporal se
with
puede escribir con circuitos clásicos,
can be
analógicos,
written with circuits,
y
classical and analog,
esa idea de los circuitos
and this
se puede usar
idea of
también
the
para o
circuits
bien
can be
simular
utilized
los
for
sistemas cuánticos de los cuales
or
estamos
simulating
conectándolos, o
quantum
hacer
areas
el
that we're connecting
salto
with,
hacia
or to make the
el
jump
uso de los circuitos
towards
clásicos o los
the
circuitos
use
cuánticos
of classical
para entrenar
circuits
modelos
or quantum
masivamente, o sea,
circuits
básicamente
to
para
train
implementar,
models,
por ejemplo, el descenso del
to
gradiente,
implement them, for
digamos,
example,
algoritmos
in
similares, ¿sí me
the
entienden?
gradient
A lo que voy con todo
and
esto
with
es
similar algorithms.
que
What am I getting at with this
lo que hay que
is,
trabajar en este campo, en la computación cuántica, esta es un poco la
well,
invitación
we
del
need to
cierre de la
work on
charla, es
this.
que
The
el
invitation of
campo
this
de, no
talk
solamente de computación cuántica, sino de
is
tecnologías
that the
cuánticas,
field
es un
of
campo
quantum or
multidisciplinar,
quantum
¿no?
technology
Porque
is a
cuando
field
hayan
that is
visto, leído,
multidisciplinary.
digamos, en algún blog o en alguna entrada en algún lugar,
You've read about it
simplemente por
about a
este
blog
mínimo ejemplo que
or
acabo de poner.
somewhere.
Fíjense las
With
ideas
this
cómo fueron
example that I gave you,
transitando por
how
otro
these
conjunto de ideas,
ideas
se fueron chocando
were
con otras y surgen cosas
moving
nuevas.
from another type of
Entonces, si uno
ideas.
realmente quiere innovar o quiere
So if you really
trabajar
want to
en
innovate,
estos temas, es
to
importante
work
que
with
primero, bueno,
these
interactúe
type of
con mucha
topics,
gente,
it's
que
important
interactúe, que
to
hable, que intercambie ideas
interact
de
with a lot of
diferentes otros
people
campos, con gente de
and exchange
química, de
ideas
biología,
of
con
different
gente de
fields,
fisiología,
people
con
with
gente de
different
psicología,
in
lo mismo acá,
chemistry
en
or
cualquier área.
biology or
Hay
doesn't
muchos
matter.
sectores que
There's a lot of
potencialmente,
different sectors
digamos, se les podría
that
aplicar
potentially
ideas como las
we
que
could
está ofreciendo la
apply
computación
these
cuántica,
ideas to,
la inteligencia artificial,
like
ya
the
lo
quantum
sabemos,
computing,
y están esperando a que
AI, as we
sean,
know, and
sean
they're
descubiertas,
waiting
sean visitadas por nosotros.
for
La única
these to
manera de
be
hacer eso es
discovered or
ponerse en contacto
visited
con
by us. So
unos
the
con
only
otros,
way to do
intercambiar
this is
ideas.
to be in contact with
Lo
other people
importante de hacer
and
esto es
exchange
que
ideas.
hay también un
And
ejercicio
the
previo que
important
hay que
thing to
hacer,
do is also
y
a
que,
previous
bueno, por
exercise
prueba y
that we
error
need to do
se va modificando, se va haciendo cada vez más eficiente,
with
quizá,
trial and
que es el
error
de
can
poder
be modified.
adaptarnos en la forma de hablar
That's being
con
able to
distintas
adapt
disciplinas,
our
porque
way
no
of
es igual,
speaking
para
with
nada,
different disciplines
cómo
because it's not the same
razona, cómo
at
concibe
all.
un problema, el mismo
How
problema,
someone reasons or
una persona que
conceives a
hizo, que
problem,
tiene
even if
formación
it's the same
en
problem,
informática,
someone
en
that
ingeniería electrónica,
has
en física,
informatic
en
training
matemáticas.
or
Entonces, acá
electronic
hay una visión que
engineering
intentó
or
ser
physics or
una parte
mathematics
formal, pero no tanto,
with the
por
vision
cuestiones
of
de tiempo y
someone
demás,
that has a
pero
different
también se podría
formal
hacer con más
upbringing,
rigor, incluso todo el
but can
proceso
also
que
be
termina
done
enriqueciendo, o con mucho
with a few
menos, de pasar
intermediate
directamente a las
steps like I
aplicaciones
was doing,
y
or
saltear toda
someone
esta
with
parte de
much less and
fundamentos.
then
En fin, hay
jump
muchas
straight
maneras de
into
trabajar.
applications.
Lo importante es,
However, there's many ways
bueno,
of
estar
working,
con la cabeza
and the important
abierta,
part is
hablando
to
con todo el mundo,
have an
aprovechar
open
también
mind, talk with
el canal
everybody,
de
and take
Discord también para
advantage
poder hacer intercambios
the
de ideas
Discord
y de
channel to do
proponer
exchange of ideas there
dudas y
and
cuestiones que tengan.
propose
También los invito a dejar
any
sus
doubts or
preguntas
questions that you might
en el
have.
mismo canal de Discord.
And I invite you to
Y
leave
nada,
your
esto
questions
simplemente los
there
dejo
in
con
the
los
Discord
efectos especiales
channel.
del
And I
inicio.
leave you with
Muchísimas gracias por estar ahí.
thank you so much for this time.
Okay, thank you, Hylan. And the moment you've, oh, I turned off my camera. Let's see. There we go. The moment you've all been waiting for, the award ceremony. Before that, I would really like you to take a moment and ask questions for Mariano in the Discord channel. He is going to be answering them, and he is looking forward to interacting with you if you have questions related to the master's program or anything that he brought up. So, take advantage of the opportunity to get some of the speakers answering your questions on the Discord channel. All right, that said, we have tomorrow is our last in-person event in Cary, North Carolina. We are going to be at La Buena Vida in Cary, so make sure that you register, because based on that, we will order food. So don't make us have less tacos, please. All right, let's go to these slides. I'm going to share this presentation again, and then we're going to go to the award ceremony. I shared a little bit about the notebook that Grazia did for the drug discovery. I'm also going to be adding a notebook on ADAPT VQE. So it is used for molecular material science problems. Hussein Shiri from Lebanon created it. We also have quantum error correction and phase kickback from Deval Verma. These notebooks are exceptional. We also have max cut and the grouping problems from McCool. And there's a couple of other things that were developed by our interns. So I really invite you to take a look at that folder number 4. And we are going to stay in the Discord channel, so we can continue networking and such. If you have a suggestion on something that you would like to continue, like one of the certifications, just let us know. Here is what I shared with you last week. Again, just look them up, and the links should be in the presentation also. Now, if you want to get that IBM badge directly from them, just make sure that you go into the learning quantum.ibm, and all right, drum roll. But before we give that out, I would like all of our interns to turn on their cameras. We are going to give them a moment for a spotlight. I don't think I was sharing my screen. All right, where are the interns? Here we go. Please unmute yourself and say hi so you get bumped up.
Hello. Hello, good morning.
Hello, good morning.
Hey, how's it going?
Hi, Pranit. We have Sadikin and Grazia and Fabian. We have Harshit. We have some of our mentors here. Let's see. All right, we have Faniza. I see her. All right. Let me scroll down. I don't want to miss anyone. We have Jimena. Jimena Leon. We also have, I'm just looking over here. To the participants, if you feel like you have benefited from the content they've developed and from all of this, if you could please join me in a round of applause. Like I said, if there's something that you would like to say that about the content that they created that was meaningful for you, please do so. So big round of applause. Thank you for a job well done. This is really this is a group effort, and we really appreciate everything that you have done and the kind of quality interactions. They had to go through several revisions and stuff, so we very much appreciate the effort. The intern ceremony for awards for the best intern, the different achievement levels is going to be held next week, so I will be sending that out. But for now, we are going to grant our prizes. All right, here we go. Let's just go here. present this. Okay, so I think I've admitted everyone so far. Here's what we were working towards, right? The IBM Hackathon sponsored by CNCA, Quarks Interactive, IBM Challenge, also sponsored by Quarks Interactive, and the Humanitarian Challenge, sponsored by Enluz and CNCA and ILN as well. So here's what needed to be done. So what are we winning, right? The computing time from Cabré. We also have Quantum Odyssey licenses to continue learning quantum computing in an interactive way. We had the Transpilers notebook with Vanessa developed the video for. And if you went the extra mile and you learned how to do that on your own, you are going to win a couple of these licenses as well. And then the Humanitarian Challenge. We have Ayelen is also one of our sponsors for this, and she is Ayelen, correct me with the naming. It's a test to prepare for the developer license test. So she has the specifics on that, but it's a voucher for a test that you can take. We have computing time on Cabré, and then we have an education or research grant, which I will be granting. Very well. Our first round of winners is for IBM Hackathon. So Deval, I don't think that he is on the call because it is a very, very early, I think, in India. So first place goes to Deval Verma. The way that he, this was picked by a group of judges, but the different optimizations that were given here and how many visualizations to show the iteration and the difference in the randomness was just exceptional. Documentation is really important when you are presenting your awards and your challenges. So for those of you that submitted, it's good to have your notebooks so we can see things, and it's also really good for you to do summaries where you walk us through what you did, so the judges can truly understand. Second place goes to Francini Corrales Garro, Dani Valerio Ramirez, y Josué Valerio Ramirez. Great job for this group effort. Also presenting different optimizations and visualizing it. I do not think Nitesh is actually present either. Bueno, do we have Francini, Dani Valerio, and Josue present? If you are, it would be great if you turn on your camera and share with us. Let's see. Okay, I do not. I think I saw them previously.
Hola, yo ando por aquí.
Hola, Francini, felicidades. Josué, felicidades.
Hola.
Congratulations, and
Muchísimas
Dani
gracias.
Valerio.
Gracias.
You're welcome. So, the brothers Valerio Ramirez, Josué, and Dani have been quite ambitious in their undertaking of these challenges, I must say. So, and Francini partnered with them for this, and they have won second place. I do not think that Nitesh is present, but I will, so can you just tell us where you're from really quickly? And if you could tell us your, where you're from and what your field of study is. Just Francini, Josué, y Dani.
Bueno, tal vez puedo empezar yo. Perdón que no ponga la cámara, no estaba preparada.
No,
Estaba despeinada.
No se preocupe.
Bueno, bueno, en mi caso, yo soy de la Universidad Nacional acá en Costa Rica.
In my case, I'm from the
Bueno, ahí
National
a Dani
University
y a
here in Costa
José los
Rica.
conozco por ahí también.
Dani and Josue, I
Entonces,
know them from here.
Sí, somos del
So
área bueno,
yes,
ingeniería en
we're
sistemas
from the area of
y andamos por ahí.
system engineering,
Por esos,
and
por
we're
esos
here
campos.
in Costa Rica
Ujú.
Sounds good.
in these
Daniel,
fields.
Josué, anything you would like to say?
Muy buenas noches a todos. Muchísimas gracias.
Good evening,
Sí, bueno,
everybody.
como
Thank you so
mencionaste,
much.
Dani y yo somos
I would
hermanos.
like to mention, as
Ambos, al
Danny
igual que
said,
Francino,
we're
somos de la
brothers.
Universidad Nacional de Costa
We're
Rica.
from the
Igual,
National
graduados de
University
Ingeniería de
of Costa
Sistemas.
Rica,
En el caso de
and
mi hermano,
from
él, bueno,
system
se enfoca un poco más
engineering,
en el
and
área
from
de
my
análisis de
brother's
datos.
case,
Y en
he's
mi
more in
caso,
the
soy,
data
bueno,
analysis area,
ingeniero de DevOps.
and in my case,
En
I'm
realidad,
a
muy agradecidos
engineer
con
of
ellos. En mi caso, sí, sí
UPS,
entré a lo que fue
and
estos
I'm very
cursos
grateful
bastante
because of these
junior, podría decir,
courses. They're
con muy
very,
poco conocimiento en todo este
I'm very
tema y
junior with
creo que ha sido de
not a
mucho
lot of
provecho.
knowledge in this
Hemos
topic,
aprendido
but it's
bastante y
been
ha
very
sido muy,
fruitful.
muy interesante
I've learned a
participar
lot,
en las
and it's been
competencias.
very
Muchísimas
interesting to
gracias.
participate in the
Gracias a ustedes. Thank
contests.
you.
So thank you very much.
Okay. Very well. So then let's go on to the next award. We have, let me share my screen so I don't go forward. All right, well, I'm trying to make the presentation go one by one, but it is not wanting to do it. So we're just gonna give you the gift overall. So for the Transpiler Challenge, the brothers you just heard who were new to the field won first place. Now I'll tell you why we have two of first place, because they must have hit enter at the same time because they arrived at the same time. So speed and accuracy were really important for this one. And so we have given them first place. Second place, Daniel Mejia. Daniel, si estás presente, please unmute. Y Anthony Andino, felicidades, congratulations to you both. All right, so let's, if you would like to tell us where you're located, what country you're in, and your field of study, that would be great. Daniel Mejia.
Buenas.
Hola, felicidades, congratulations.
Muchas gracias. Disculpe que no prenda la cámara, pero es que estoy en el escritorio y no la tengo.
Tranquilidad.
Sorry, I can't turn on my
Yo también
camera.
soy de
I'm at
Costa
the
Rica,
desktop
soy
and I don't
del
have it.
TEC,
I'm
de
from Costa
Ingeniería
Rica as
Electrónica.
well. I'm from the Tech of Engineering, Electronic Engineering.
That's where I went to school, and that's what I studied, so.
Amor al TEC, sí.
Love to the Tech.
Pura vida, Daniel.
Yes.
Y
Pura
Anthony
vida,
Andino,
Daniel.
are you on the
And
call?
Anthony Andino, are you on
I think I
the
saw
call?
you. But if I remember correctly, Karime, do you see Anthony on the call? So my understanding is Anthony does not have a technical background either. This was his first interaction with quantum, so it is quite impressive. So to everyone who has helped prepare these folks, amazing, outstanding job. And I would like to also showcase Pranit. He is, if Pranit, could you unmute yourself and tell us just briefly, so let me tell you about this. When we developed this material, we did it with the intent to bring diversity in thought, diversity in understanding, diversity in how we not only translate things from something very complex to something humorous, but how can we explain it in a simple way that doesn't have to be explained so complex. My personal journey was every time I tried to learn quantum, because I've been I've been a quantum enthusiast for some time, but up until this year, it wasn't until I was able to finally get into programs that helped me learn it well. I kept finding things that were not basic. It did not explain things from a basic level. And so we worked together with Pranit to develop some guidelines on how to create the content. And I just want him to tell you a little bit about where he is in his educational career. And he's working on a very impressive project. Pranit?
Yep. Yep. Thank you. And yeah, so my name is Pranit, and currently in my educational career, I'm still looking around a bit, deciding like which field I want to go into specifically. I'm in high school, and one of the like I want to probably go into like computers, and I'm thinking about quantum, and like the project you were talking about. So basically, like it's to help special education classrooms that have financial shortages with teaching curriculum. It uses a couple statistical methods like random sampling and then confirm and then basically like using the experimental data to determine the strengths of the students and then modifying the curriculum to match those strengths using things like generative AI and a couple other like determinations that we have called inputs and outputs for different curriculum types. And yeah, it's just like it's a project I've been working on for a couple years now. And a lot of the principles of it that we're following are based on what special education classrooms use. And those are like some of the fundamental principles of how you can create accommodating curriculum to make sure that the most amount of people can like understand it and not be like overstimulated or distracted because of it. And that's some of the stuff that I stressed in like I basically like I shared a document and talked a bit about some of the ways that we should create our curriculum and make it so that it can be as accommodating as possible. And I just like talked a bit about those principles and how we can address that in these lectures.
Thank you so much. And the reason why I showcase this especially is because each and every one of you has the ability to do this in the and a unique way in which you see the world. And so please know that there is so much value in how you can explain things once you have understood it, that that you should give it a try. This was also to showcase our talent, emerging talent. So all the creations, their videos are going to be on YouTube. Their notebooks are going to be public. Share them. People may not be able to get the certificates that you have obtained weekly, but let me tell you something. We started, we had 90% engagement from the people that registered. Of those 90%, we were close to 75 to 80 pass rate in weekly certifications of competency. So never underestimate learning from a peer and being a student and a teacher at the same time. So we thank you for staying engaged, for being part of this, and for giving yourself an opportunity to try something new. And without further ado, I'm going to announce our last set of winners, and then we're going to go into one more thing, and then we're going to wrap it up for today. So a little bit of background as to why we chose these winners is there was a couple of different aspects, right? One had to do with the impact area, the technology application, and did you speak about, for example, where you would, where the impact would be? And so Daniel Mejia has an idea about the local healthcare system, which had been hacked. And there was quite a bit of impact to the access to critical specialty appointments. And so he suggests something related to encryption that considers lava lamps, which I thought was very creative. And he is our first place for the humanitarian challenge. So congratulations, Daniel Mejia.
Thank you very much.
You're very welcome. Hugo Christian Ojeda. So Daniel, you've already heard from him. He's from Costa Rica. Hugo Christian Ojeda. I do not think, is he, Ayelen, is he on the call? I don't think so, right? I don't think he was able to make it today. But anyway, Hugo has, he is from Argentina, and he also presented a, his project was quite impressive, actually. I'm going to pull up what he mentioned because I don't think I can speak of it from memory, but it has to do, well, now I can't find it. Okay, hold on. Okay, so it was about piezoelectric materials to convert urban noise into electrical energy. Now, this was quite impressive, and I have to tell you that I was really torn between who the first place would be. But if you want to talk to Hugo about this, the way that he talks about the piezoelectric systems in urban infrastructure not only considers the material science, it considers the conductivity, urban development, crystal lattices and materials. I mean, it is outstanding. So Hugo is quite willing also to stay in contact and continue networking. He has a team in X Prize. So talk to him about that, and make sure you network. He was present in a lot of those networking sessions, open office hours and networking sessions that we had. So keep an eye on that. Now, our third prize is for Phoenix, and Phoenix also talked about the healthcare system. And I'm just going to pull up his presentation so I do not butcher what he has suggested. And Phoenix, are you present on the call? I do not think that I saw Phoenix. Just pull this up. Okay. So Phoenix suggests, just go, healthcare decision support system. Now, in his decision support system, there's a lot of optimization algorithms that are mentioned, and the way that it is, the suggestion of optimization has to do with delay of care in diagnosing. Sometimes, you may have something that is quite aggressive, and you may have to wait a couple, like 10 years ago, you had to wait 2 weeks for a biopsy. Now you have to wait maybe 48 hours, 2 days, a day, maybe 3 to 4 days. It depends on both the imaging system, the whether the radiologist read the report, did it go through different things. So it's like, if it's something that's life or death, right, how critical, if you're not in the ER, is the timing, and it is quite critical. So this proposal was rather impressive in terms of the optimization for the decision support system. All right, so to the interns, this is a true testament to everything that you did, all the hard work, everything that that the core organizers, yourselves, and all of our sponsors and partners did. So our next networking event, come meet us, see if you're interested in staying in touch to talk about possible research opportunities. We're going to be bringing groups together, study groups, to talk about the what people are interested. If you're taking these badges and you want to kind of have some folks to talk about, the different exercises or the tests, you can continue in the Discord server. We're going to change some of the channels so you can continue the conversation there. For those of you who went to the Python focus camp, we're going to see if we put something together so you can perhaps get a certification there. And with that, I feel like we are at our at the end of our session. So I really want to take a moment to thank you, and also to in every quiz that you had, there was a message that many times when I've undertaken new things, I remind myself that successful people aren't those that have everything go well. If you look throughout history, successful people are those who are willing to fail until they succeed. Congratulations for giving yourself the chance to try something new, something hard, and to meet new people. A lot of the co-organizers here, some of them had never met until we said, hey, do you know here, this, that, the other? And thank you, Johan. And the power of networking is very important. So if I'm going to stop the recording, I'm going to thank you all for the opportunity. Felicidades, congratulations, incredible team. And I'm going to stop the recording. And if anyone would like to unmute and just tell us, you know, maybe introduce yourselves, we'll be here for the next maybe 15 minutes. I'm going to, you sure?